As November deepened, the global eye became more than an initiative. It became a living ritual. Each evening, as cities dimmed their lights and families glanced skyward, there was a shared awareness that countless others, across continents, were doing the same. From rooftops in Cairo to fields in Kansas, from Himalayan outposts to Pacific islands, people lifted their gaze toward the same green haze. It no longer mattered whether one peered through a billion-dollar telescope or the naked eye. What mattered was the act of looking, of refusing to let the silence of Atlas isolate us. For the first time in years, humanity seemed to inhabit a single conversation, one where the language was wonder tempered by caution. The data streams thickened into archives of staggering scope. Terabytes flowed daily into central repositories where algorithms labored to find coherence. Patterns flickered, though none yielded full answers. There were hints, subtle pulsations in brightness, whispers of geometric symmetry in the coma's shifting veil. Yet each clue ended in ambiguity, a trail dissolving into fog. Still, the collective refused despair. "We are mapping the unknown, pixel by pixel," one Japanese researcher wrote in a midnight dispatch. That phrase, pixel by pixel, became a mantra of sorts, echoed in conference halls and shared across social feeds. It captured both the humility and the resilience of the moment, the acceptance that the unknown would not be conquered in a single revelation, but assembled slowly, cautiously, through the patience of countless eyes. Stories emerged from within the network that gave the effort a human face. A technician in Nairobi, running on 3 hours of sleep, noticed an irregular flicker and flagged it, only to learn it aligned with similar observations from telescopes in Arizona. A school in Manila projected nightly updates onto its gymnasium wall, turning science into a community gathering. In Warsaw, a small team of astronomers live-streamed their telescope feed, drawing thousands of viewers who for the first time felt directly connected to discovery. These vignettes stitched together a larger truth, that knowledge was not being generated in ivory towers alone, but in living rooms, classrooms, and improvised labs across the world. Hope swelled from these connections, but it was a careful hope, one always laced with restraint. Everyone knew the silence persisted, the central enigma unmoved. Atlas had not relented, had not given the frequencies or signatures that would collapse the mystery into clarity. Yet the collective effort had changed the story. No longer was humanity waiting in fear for the next inexplicable shift. Now it was waiting together, eyes interlocked, minds converging. That difference mattered. The silence remained unnerving, but it no longer felt isolating. Instead, it felt like a canvas, one against which billions of minds could project their questions, their resilience, their solidarity. When the first official summit of the Global Eye convened virtually at the end of the month, the moment carried the gravity of a new epoch. Delegates from over 50 countries shared screens, their backgrounds filled with glowing graphs and live images of Atlas. No breakthroughs were announced, no dramatic answers were found. Yet when the meeting closed, participants lingered in silence, not the silence of Atlas, but the silence of recognition. They understood they were part of something unprecedented, not merely an investigation of a comet, but a rehearsal for a different kind of humanity. For once, the world was practicing unity under the gaze of the unknown. And as the session ended, one closing remark echoed louder than any dataset. It came from a veteran astronomer in Chile who had tracked comets for 40 years. His voice trembled slightly as he said, "We may never solve Atlas in our lifetime, but we have learned something rarer. The sky is vast enough to belong to all of us, and the only way forward is to look at it together." The line was repeated across headlines the next day, a quiet anthem for a fragile age. Beneath the emerald lantern of Atlas, humanity had not found answers, but it had found each other. And that, for the moment, was enough. By late November 2025, as the Global Eye continued its vigil, a new phrase began circulating in the nightly reports: the coma paradox. For weeks, observers had been mesmerized by the emerald shroud that swelled around Atlas, expanding faster than any model predicted. But the more brilliant this halo grew, the less visible the core became. It was an inversion of expectation. In most comets, the coma, those vast clouds of dust and gas released as sunlight warms, the surface remains a translucent veil, enhancing but not erasing our view of the nucleus. With Hale-Bopp in 1997, for instance, the coma dazzled observers, yet astronomers could still trace the stubborn outline of its icy heart. With Hyakutake in 1996, the coma stretched across half the sky, but instruments still caught glimpses of the body at its center. Atlas, however, seemed intent on hiding itself. Its coma was not a veil, it was a curtain drawn tight, an emerald stage light that illuminated everything but the actor behind it. Technically, the coma is expected to thin as it expands, its density diffusing across space. Yet in Atlas, the opposite appeared to be happening. Each successive image suggested the green haze was thickening, congealing into a luminous fog so dense it swallowed starlight behind it. Background constellations vanished when Atlas crossed their path, not because the comet blocked them physically, but because its coma absorbed their light into its emerald glow. Astronomers described it as watching the sky be erased, pixel by pixel, behind a rolling curtain of green flame. Instruments tuned to analyze the spectral signature of common gases, water vapor, carbon monoxide, cyanide, did indeed detect traces. But those traces were drowned out by an intensity so disproportionate that no known chemical ratios could explain it. It was as though the comet's coma had found a way to amplify itself, a natural lens magnifying its own luminosity. The paradox deepened with every attempt to model it. Supercomputers were fed terabytes of data, coma size, expansion rate, spectral readings. Each run produced simulations that quickly collapsed into nonsense. To generate such brightness, the comet's nucleus would need to be shedding material at a rate 10 times higher than the most active comets ever recorded. But that level of activity should have destabilized it, breaking the body apart into fragments. Yet Atlas remained intact. In fact, there was no clear measurement of its nucleus at all. The coma not only masked the core, it overwhelmed every instrument designed to peer through it. "We are blinded by light," one astronomer remarked. Her words carried through the shared networks like an epitaph. The paradox was simple but brutal. The more Atlas revealed, the less it allowed itself to be seen. Public fascination only grew with each report. Images of the coma filled newspapers and digital feeds, great emerald discs glowing against the velvet dark, captured from mountaintops and backyards alike. Artists rendered it as a living eye, a cosmic lantern, a green storm. Commentators leaned on metaphors, the coma as a mask, a shroud, a fortress. In classrooms, teachers explained to students that they were witnessing a cosmic irony. Light meant to reveal had become a barrier. Children drew pictures of Atlas as a creature hiding behind a veil, peeking out with a single glowing eye. The scientific community, meanwhile, balanced its awe with unease. They knew that to understand the paradox was to edge closer to the heart of the mystery. But for the moment, they could only admit the truth. The coma was growing, the core was vanishing, and Atlas had turned the tools of observation into instruments of blindness. As December opened, the paradox refused to yield. Every night, instruments probed deeper, and every morning, analysts confronted the same stubborn enigma, a coma that grew brighter, denser, more magnificent, yet no closer to unveiling its source. The irony gnawed at the scientists. They were drowning in data yet starving for clarity. Algorithms churned through spectral patterns, teasing out familiar fingerprints of cyanogen and hydroxyl radicals, but the expected ratios were distorted beyond recognition. It was as if someone had taken the chemical alphabet of comets and scrambled it into a language that glowed but could not be read. The frustration became palpable in the reports. Researchers who usually spoke in guarded tones began using words like unnerving, opaque, and unreasonable. At Caltech, one team proposed that the coma was behaving like a plasma mirror, reflecting and amplifying solar photons in ways that ordinary cometary physics could not predict. Yet when the theory was run through simulations, the models collapsed. The brightness should have fractured the nucleus within days, leaving a trail of fragments across the sky. But Atlas remained whole, a ghostly nucleus hidden behind its wall of emerald fire. In Zurich, another group hypothesized that magnetic fields were somehow trapping charged particles, corralling them into a luminous shell. Their equations looked promising until the field strengths required turned out to be orders of magnitude beyond anything plausible. Every solution unraveled. The paradox held. What made the process so excruciating was the visual clarity. Unlike the deep mysteries of black holes or dark matter, which hid themselves in invisibility, Atlas flaunted its presence. Night after night, telescopes delivered images of breathtaking sharpness, curtains of green light folding and refolding like veils stirred by an unseen wind. The coma was not static. It writhed, pulsated, shimmered with subtle waves, as though responding to a rhythm beyond human hearing. Observers described the experience as watching a heartbeat in light. Yet that heartbeat never aligned with the physics they knew. If anything, the spectacle deepened the suspicion that the coma was not merely concealing the nucleus, but protecting it, guarding the truth at the center, like a fortress guards its king. The public followed these developments with equal parts fascination and anxiety. Documentaries aired nightly recaps, intercutting expert commentary with dramatic visuals of the coma's expansion. Social media brimmed with comparisons. Some likened it to the aurora borealis unfurled into space, others to a cosmic eye staring unblinking at Earth. But among the awe, there was unease. Viewers asked the questions scientists could not answer. What is it hiding? Why does it not break apart? The phrase, the emerald mask, gained traction, a poetic echo of the paradox. The mask dazzled, yes, but also provoked the oldest of human instincts. The fear that behind every mask lies something unknown. Inside the Global Eye network, the paradox became the focal point of endless late-night debates. Teams traded not only data but doubts, sketching possibilities on whiteboards, erasing them in frustration. In a symposium streamed from Tokyo, a veteran comet specialist admitted, "It is the first time in my career that more light has meant less understanding." The audience of peers nodded grimly. They knew the paradox was not just scientific, it was existential. Atlas was teaching them that the very tools designed to illuminate truth could also blind, that sometimes the universe revealed itself in ways that deepened rather than dispelled mystery. And yet, despite the exhaustion, the sense of suspense only sharpened. Each new observation felt like peeling back another layer of the green curtain, only to find more curtain waiting. The paradox was no longer just a puzzle. It was a performance, one that left its audience leaning forward in their seats, hearts quickening with the hope that the next act might finally unveil the hidden stage. For now, the emerald haze held its silence, daring humanity to keep watching, keep questioning, keep feeling the pull of both wonder and dread. By mid-December 2025, the paradox had taken on an almost mythic weight. Scientists no longer spoke of studying Atlas so much as enduring Atlas, as though the comet were less an object and more a condition imposed upon the world. Its coma stretched across millions of kilometers, now so immense that instruments struggled to define its edges. Photographs captured it, dwarfing entire constellations, a luminous veil swallowing star fields whole. And still, the nucleus remained invisible. Each attempt to pierce the haze with radar pulses or high-energy scans was absorbed, scattered, or rendered meaningless by the emerald fog. "It's like trying to X-ray a thundercloud made of mirrors," one engineer muttered, encapsulating the frustration of thousands. Yet the very impenetrability fueled suspense. Each night's session began with the same ritual. Telescopes swung toward the green lantern, data streams poured in, and researchers leaned closer to the monitors. Perhaps tonight, the haze would thin. Perhaps the curtain would lift for just a heartbeat, offering a glimpse of what lay beneath. That anticipation threaded itself into the culture of observation, a quiet, collective thrill tinged with dread. For what if the curtain lifted and revealed something worse than ignorance? The paradox was not merely about visibility, it was about the terror of revelation. Humanity had grown comfortable with the idea that mystery would yield to method, that patience would eventually win. Atlas mocked that assumption, dangling the possibility of truth while ensuring it remained just out of reach. Comparisons proliferated. Some likened the coma to a stage light so blinding that it hides the actors, others to a cocoon, protecting whatever transformation was happening inside. The analogy of metamorphosis unsettled many. If Atlas was a cocoon, then what was it incubating? Scientists resisted the metaphor publicly, but privately, the idea gnawed at them. Observers in Chile whispered about rhythmic pulses in the coma's brightness, too subtle for mainstream announcement but real enough to notice. A team in Canada suggested these pulses might correspond to rotational dynamics of a massive, oddly shaped nucleus, but the data was too noisy to confirm. In the absence of certainty, imagination filled the void, and with imagination came suspense. The paradox also forced a new humility upon the community. At international briefings, scientists began to acknowledge limits openly. "We are learning that more light does not always mean more knowledge," a Paris-based astrophysicist said. "Sometimes it means the opposite. Sometimes light blinds." The admission struck a chord. Journalists quoted it across headlines, and the phrase entered public discourse as both warning and wisdom. In classrooms, students debated whether humanity had been naive to think every mystery would bow to technology. In households, families watched documentaries that framed Atlas less as a comet and more as a parable, a reminder that some truths resist unveiling, even under the brightest scrutiny. And yet, beneath the caution, a current of exhilaration remained. For all the frustration, the paradox was alive. It drew people together across languages, disciplines, and generations. It transformed quiet evenings into vigils of discovery, turned skepticism into a form of shared suspense. No one knew when, or if, the coma would relent, but everyone felt the pull of anticipation, the possibility that tomorrow's data might break the pattern. That blend of wonder and anxiety kept the world looking up, night after night, refusing to turn away. As the year edged toward its close, the coma paradox crystallized into a single haunting image, a curtain of emerald light that revealed nothing, yet demanded everything. It demanded time, patience, humility, and imagination. It demanded that humanity confront the limits of its sight and the fragility of its confidence. And though the curtain never lifted, its presence became revelation enough. For Atlas had taught a lesson deeper than any single discovery, that the universe is not obliged to unveil itself on human terms. Sometimes it dazzles precisely to conceal, sometimes it blinds precisely to remind us that mystery endures. And in that paradox, humanity found itself suspended, awed, unsettled, but still watching, still waiting, as though standing before a stage where the greatest performance had not yet begun. By late December 2025, the coma paradox had hardened into a fact of life. Atlas glowed brighter each week. Its nucleus remained hidden, and every model failed to tame it. Within this silence and glare, a more troubling question began to emerge, whispered at first in specialist meetings, then spilling slowly into public reports. If the comet truly was as massive as the coma suggested, if its hidden nucleus were not the modest fragments typical of interstellar visitors, but something far larger, then the implications extended far beyond academic curiosity. They threatened the foundations of celestial prediction itself. The reasoning was stark. A nucleus 10, 20, or even 50 kilometers across would carry a gravitational pull far stronger than any prior interstellar body observed. Even without an Earth-crossing trajectory, such mass could nudge neighboring orbits, perturb the delicate balances of dust and plasma in the inner system. Astronomers remembered the lesson of Shoemaker-Levy 9, the comet that shattered and plunged into Jupiter in 1994, leaving scars the size of Earth on the gas giant's atmosphere. That was a body less than 2 kilometers wide. What, then, would a giant 10 times that size be capable of, should its course ever shift? Of course, no one suggested Atlas was on a collision path. The orbital mechanics remained clear. It would swing past the Sun, cross Mars's neighborhood, and arc back into interstellar darkness. But the very act of considering its bulk forced scientists to confront uncomfortable scenarios. What if its expansion signaled not only sublimation but instability? What if the nucleus fractured into a swarm, each fragment carrying the mass of a city, and those fragments followed unpredictable trajectories? The coma hid the answers, leaving only speculation. And speculation, in the absence of certainty, breeds unease. Within the Global Eye network, debates sharpened. Some urged caution, reminding colleagues that brightness alone does not equal mass, that resonance and plasma dynamics might account for the exaggerated coma. But others pushed back, noting the stubborn silence in other wavelengths, the persistent failure of models. If we assume Atlas is ordinary, one researcher wrote bluntly, then we must accept that our instruments are failing. If we assume our instruments are correct, then Atlas is extraordinary. Neither choice sat comfortably. The paradox of the coma had become the paradox of implication. Whichever way the data pointed, it threatened to destabilize trust either in the tools or in the universe they measured. Public outlets caught fragments of this debate, amplifying them with the urgency of news. Headlines spoke of a comet too big to ignore and the monster behind the mask. Commentators drew uneasy analogies to climate change and pandemics, events humanity saw coming but preferred not to imagine until it was too late. The tone was not panic but a careful warning, a hum beneath the surface of celebration and awe. For the first time, the question was not simply what Atlas is hiding, but what does its hidden truth mean for us? And that was a question whose answers, however tentative, were bound to unsettle. The unsettling weight of Atlas's presence did not rest only on the shoulders of astrophysicists. It began to ripple outward, seeping into conversations among engineers, policymakers, and even philosophers. For decades, celestial mechanics had been held up as one of the most precise sciences. Planets and comets obeyed predictable laws, their orbits calculable centuries in advance. Now, with Atlas blazing like a green phantom and refusing to conform, people asked what else might slip through the neat geometry of prediction. If a comet could mock our equations, what of the countless other bodies wandering the interstellar dark? In quiet rooms, space agencies entertained scenarios they avoided voicing in public. If Atlas did carry an unusually massive nucleus, even its distant pass could alter dust streams and trigger secondary effects. Solar-wind interactions could be intensified, nudging magnetic storms toward Earth's fragile satellites. The coma's density raised questions about how much debris might be left behind, invisible, until it intersected with orbital lanes crowded by human technology. None of these scenarios spelled catastrophe in the cinematic sense, but each hinted at disruptions, communications, blackouts, satellite damage, unpredictable atmospheric disturbances that modern civilization was poorly prepared to face. It was not an existential threat, it was a vulnerability, one that grew more uncomfortable with each unanswerable question. Scientists, for their part, struggled with the communication gap. How could they convey the seriousness of the implications without inciting panic? In interviews, their voices carried careful restraint. There is no immediate danger, but Atlas challenges our understanding. To the public, those words sounded paradoxical, even evasive. How could something so luminous, so dominating in the sky, be both harmless and unsettling? The unease deepened not because scientists spoke of doom, but because their hesitations betrayed a quiet fear that the tools of certainty might no longer be enough. Philosophers seized on this tension. Some argued that Atlas had become less a comet and more a mirror of human hubris. For centuries, humanity had assumed that the universe, if scrutinized hard enough, would yield its secrets neatly. Atlas, cloaked in its paradoxical coma, suggested otherwise. It was a reminder that nature could still withhold, still resist the neat categories of science. The implication was not apocalyptic, but humbling. Perhaps the real danger was not what Atlas might do, but what it revealed about our fragile sense of mastery. Amid this atmosphere, cultural echoes spread. Writers compared the comet to an ancient oracle, radiant, indecipherable, unsettling in its refusal to answer. Artists rendered it as a glowing mask, the universe's way of hinting at truths too large for human comprehension. In classrooms, students debated whether Atlas represented a scientific anomaly or a philosophical warning, and in cafes and online forums, ordinary people confessed to a creeping unease. Not fear of collision, but fear of uncertainty itself. The comet had become a symbol of discomfort, a reminder that the universe remained wild, untamed, and far less predictable than we wanted to believe. What made all of this so delicate was the tone. There were no doomsday sirens, no official alarms. The warnings were softer, subtler, the kind that seep into the mind and linger. Scientists described it as a stress test for knowledge, a cosmic audit of our ability to interpret the unexpected. The implication was uncomfortable, not because Atlas threatened immediate destruction, but because it whispered of gaps in our preparedness. And in that whisper lay the seed of anxiety. If this is what we cannot explain when it passes harmlessly, what would happen if the next one did not? By the final nights of 2025, the conversation around Atlas had shifted again. The scientific questions remained urgent, but a quieter realization had settled across the global eye. The comet's greatest disruption might not be physical at all. It was psychological. Each attempt to pin down its nature ended in contradictions. Each public statement tried to balance wonder with reassurance, yet left behind a residue of unease. People had grown accustomed to believing that when the cosmos surprised us, science would respond with answers. Atlas broke that rhythm. It shone brilliantly, refused to yield its core, and left humanity staring at its own limitations. The uncomfortable implication was no longer what if Atlas is too big, but what if we are too small to understand it in time? Governments, though reluctant to admit it, began drafting quiet contingency plans. Satellite operators rehearsed protocols for unexpected surges of solar interference. Aerospace agencies rechecked impact monitoring systems, even though no collision was forecast. These were not acts of alarm but of precaution. the kind that officials never wanted to explain on the evening news. The very existence of such measures underscored the mood, not panic, but vigilance edged with worry. Atlas had become a drill without a script, a rehearsal for dangers unimagined. For ordinary people, the comet had already become a metaphor that colored their lives. In poems, it was a green wound across the sky. In films, a symbol of hidden truths. In sermons, a sign of humility demanded from humankind. Parents pointed it out to children as a reminder that the universe still held mysteries beyond textbooks. Teenagers posted photos of the glowing smear above city skylines, half in awe, half in jest. Yet beneath all these expressions ran the same current of thought. If such a thing could appear, grow, and confound us so completely, then perhaps the cosmos was far less stable than our illusions of control suggested. The implication was not just scientific, it was existential. In late December, an editorial in a major science journal captured the mood succinctly. Atlas is not a threat, but it is a warning that our models are fragile, our instruments imperfect, and our confidence easily unsettled. The line resonated worldwide, quoted in headlines, repeated in classrooms, debated in parliaments. The warning was not loud, but it was sharp, a quiet bell tolling in the back of humanity's collective mind. We were not in immediate danger, but we were reminded that danger could exist just beyond our capacity to see. As New Year's Eve approached, fireworks were prepared to light the skies of Earth. Yet for many, their eyes would remain drawn to the emerald blaze hanging above, a firework of cosmic scale that outshone celebrations below. Atlas would continue its arc, indifferent to the questions it had sparked, but the implication it left behind would linger, that the universe could, at any moment, confront us with puzzles too large for comfort, too silent for certainty. And while scientists continued to measure and theorize, the rest of humanity was left with a subtler burden, the awareness that sometimes the most unsettling truth is not what a comet might do, but what it might mean. The first weeks of January 2026 brought a shift in focus. After months of staring at Atlas's swelling coma and impenetrable silence, researchers began to widen the lens. Perhaps, they suggested, the paradox of Atlas was not only about its present form, but about its origin. Where had this thing come from? Why did it carry such unusual signatures? And most unsettling of all, was it alone? These questions crystallized into a phrase whispered across symposiums and datasets alike: the interstellar reservoir problem. The idea was not entirely new. Astronomers had long speculated about the Oort cloud, that vast spherical halo of icy bodies stretching far beyond Pluto, a kind of celestial graveyard and nursery. But what if, beyond even that, there existed reservoirs of material adrift between stars, cosmic storehouses, that occasionally sent fragments wandering into planetary systems? The discoveries of Oumuamua in 2017 and Borisov in 2019 had already cracked open the door to this possibility. Oumuamua had arrived like a sliver of interstellar graffiti, accelerating in ways that defied gravity's script. Borisov, by contrast, looked more familiar, a comet but with chemistry unlike local examples. Together, they proved one truth: objects from other stars did visit us. Atlas, however, seemed to escalate the narrative. If its coma was to be believed, it was larger, stranger, more theatrical than either of its predecessors. The reservoir problem was not only about statistics, but about probability. If 3 interstellar objects had been identified in less than a decade, after centuries of human blindness, then logic suggested the cosmos was thick with them. Perhaps our instruments had only recently grown sharp enough to notice. Perhaps the solar system was not the isolated island we once imagined, but a crossroads, a place where the flotsam of the galaxy occasionally washed ashore. For scientists, this idea was intoxicating. For philosophers, it was unnerving, because to speak of reservoirs was to admit that we lived not in a stable neighborhood, but on the edge of a busy thoroughfare, exposed to visitors we could not predict or control. In conferences streamed across continents, researchers traded equations estimating the density of such reservoirs. Some argued that billions of objects might roam unseen between the stars, fragments ejected from planetary births and deaths, drifting eternally until a star's gravity ensnared them. Atlas, they speculated, was one such fragment, perhaps born in the chaos of another sun's adolescence, carrying with it the frozen memory of alien chemistry. The prospect thrilled astrophysicists. Here, before our eyes, might be a messenger from a different system entirely, a sample of a world we would never otherwise touch. Yet the thrill carried a sting. If Atlas was indeed such a fragment, then countless others might be out there, each one a silent reminder that our skies were not as empty as we like to believe. The interstellar reservoir problem forced a mental pivot. It was no longer just about decoding one comet's behavior. It was about rethinking humanity's position in a galaxy that might be far more crowded, far more chaotic than we dared to imagine. And as telescopes tracked Atlas blazing its emerald path, people began to feel the weight of that implication. It was not just science, it was a reorientation of existence itself. As the weeks of January passed, the debate sharpened. The interstellar reservoir problem was no longer an abstract speculation. It became a central question gnawing at the foundations of astronomy. If Atlas had indeed emerged from such a reservoir, then it was not an isolated marvel, but a symptom of something larger. The cosmos might be littered with unseen cousins, each one carrying its own secrets, its own anomalies. The idea thrilled scientists, an endless library of frozen messengers drifting between suns, but it also unsettled them. For if there was a library, then we were not its curators. We were its accidental readers, stumbling upon volumes at random, never knowing which page might fall into our hands. The intellectual stimulation was undeniable. Research groups in Europe modeled possible birthplaces, running simulations of planetary systems ejecting debris during their chaotic youth. Some projected Atlas might have been flung from a binary star system, where gravitational slingshots can hurl bodies across light years. Others suggested it could be the shattered remnant of an ancient super-Earth, stripped of its identity and set adrift into darkness. These models painted vivid possibilities. Atlas as a shard of alien geology. Atlas as a refugee from stellar violence. Atlas as a traveler that had carried its silence for millions of years before wandering into our small solar harbor. Each hypothesis stirred excitement, yet none erased the unease that followed. If such wanderers were common, then our solar system was less fortress, more intersection. The implications spread beyond astrophysics. Biologists whispered about panspermia, the theory that life's ingredients could travel between stars on such icy vessels. If Atlas carried complex molecules from another system, then its coma was not only a veil of mystery, it was a chemical archive, potentially holding echoes of life foreign to Earth. The thought was electrifying, that the green haze streaking across our skies might be laced with alien biochemistry. But the exhilaration was double-edged. If life's seeds traveled so easily, then so too might its dangers. What else might reservoirs scatter across galaxies? Were we prepared to study such material responsibly, let alone survive its implications? Philosophers turned these speculations into deeper anxieties. If Atlas was evidence of a reservoir, then it hinted at a universe fundamentally indifferent to our need for order. These fragments drifted not with purpose but with randomness, collisions of probability that could alter a planet's fate without warning. Humanity, so proud of mapping its future in neat curves of orbital mechanics, now had to face a disquieting truth. The cosmos might be governed less by predictability than by chance encounters with messengers from elsewhere. The problem was not just astronomical, it was existential. We lived not in a sheltered garden but in an open thoroughfare, vulnerable to whatever the galaxy chose to send. The global eye reflected this duality of wonder and worry. Teams around the world pored over every dataset, eyes gleaming at the thought of tracing Atlas back to its birthplace. Yet in their late-night calls, an undercurrent of unease persisted. If we can't even see its nucleus, how can we pretend to track its history? One researcher confessed. Another admitted that the more they tried to project Atlas backward through simulations, the more chaotic the results became. Its origin dissolved into probabilities, each pointing to a different patch of galactic sky. The trail ended not in clarity but in fog, and in that fog lay the true discomfort. Not only could Atlas be from anywhere, but countless others might be waiting, unseen, ready to emerge at any time. The interstellar reservoir problem was no longer a question of where Atlas had come from. It had become a reminder of how porous our reality truly was, how thin the boundary between the familiar and the unknown. It stimulated minds, yes, but it also left souls uneasy. For each new possibility revealed how little control humanity had, how easily our story could be rewritten by the arrival of a single wanderer from the dark. By late January 2026, the interstellar reservoir problem was no longer confined to scholarly circles. It spilled into public consciousness, sparking late-night debates, think pieces, and even parliamentary questions. The idea that our solar system might sit on the edge of a galactic highway unsettled people in ways that raw data alone never could. Maps published in newspapers illustrated streams of potential interstellar objects sweeping invisibly past Earth's orbit, countless unseen shadows drifting through the night. The graphics were speculative, yes, but their symbolism struck home. Humanity was not living in a safe corner of the cosmos, but in a crossroads where strangers could appear at any moment. The unease became sharper when researchers highlighted the sheer improbability of our recent detections. For millennia, humans had scanned the skies with nothing but myths of wandering stars. Then, in less than a decade, 3 visitors revealed themselves: Oumuamua, Borisov, and now Atlas. Was this a coincidence of technology, or a clue that reservoirs were denser than anyone dared predict? If the latter, then we were surrounded by potential encounters, each one a dice roll of cosmic scale. This was thrilling to contemplate, but it also unsettled something deeper. The notion of stability. Civilization rests on predictability, the confidence that seasons, orbits, and skies will remain steady. The reservoir problem threatened to dissolve that comfort, reminding us that randomness was never banished, only temporarily hidden. Philosophers and cultural commentators seized on the theme. Some likened Atlas to a message in a bottle, cast into the ocean of space by a star we would never know. Others compared the reservoir to a vast cosmic memory, fragments of long-dead worlds drifting endlessly until stumbled upon by chance. The metaphors inspired awe, but they also invoked dread. If these fragments were memories, they were not gentle ones. They were shards, broken and exiled, survivors of violence written into their very chemistry. Humanity's encounter with Atlas was less a dialogue with the universe than a reminder of its brutality. Stars erupt, planets die, debris is flung into the void, and every so often those ruins drift into our skies. The green haze above was not only light, it was history, and history rarely flatters the living. Yet, amid the unease, the intellectual thrill endured. Laboratories buzzed with the possibility of studying alien geology without ever leaving home. Students were drawn to astrophysics in record numbers, lured by the romance of deciphering the unknown. The reservoir problem, for all its existential weight, had ignited imaginations. But even this optimism carried a shadow. To imagine reservoirs was also to imagine vulnerability, the recognition that Earth's story could be altered, even ended, by forces it could neither anticipate nor resist. Atlas was a gift of knowledge, yes, but also a reminder of fragility. It was both telescope and mirror, showing us the galaxy's vastness while reflecting our smallness within it. As January waned, the paradox of the reservoir resolved into a quiet truth. Atlas was not an answer but a question, and perhaps always would be. To see it blazing across the sky was to feel both enlarged and diminished, both inspired and unsettled. The interstellar reservoir problem was less about counting icy bodies adrift between stars, and more about confronting the possibility that we were never alone, not in the comforting sense of neighbors, but in the disquieting sense of debris, of fragments, of strangers who do not speak. In that realization lay the true weight of Atlas. A stimulation of the mind that left the heart uneasy, a reminder that the universe owes us no comfort, only truth in its raw, unfiltered form. By February 2026, anticipation reached a new pitch. Atlas, the emerald giant that had defied models and silenced instruments, was now on approach to the orbit of Mars. Astronomers called this phase the crossing geometry, the critical juncture where the comet's path would weave through the orbital lane of the red planet. The mathematics of the moment filled screens worldwide, diagrams of ellipses, curves of velocity vectors, heat maps of possible dust dispersal. It looked almost like the weather reports that precede a hurricane, except the storm this time was not forming over oceans but in the vacuum of space. The numbers were sobering. At closest approach, Atlas would pass within 0.07 astronomical units of Mars, about 10 million kilometers, close enough for its coma and dust tail to brush the Martian environment. The comet's velocity, relative to Mars, was staggering. Over 50 kilometers per second, a cosmic bullet trailing an emerald wake. For Earth, this posed no direct danger, but for Mars and the fleet of machines orbiting it, the geometry raised unsettling questions. Would the thin Martian atmosphere glow with auroras as Atlas's charged particles swept past? Would the comet's dust impact satellites, pitting their surfaces or even disabling their instruments? Or would the crossing be nothing more than a silent flyby, dazzling to watch but harmless in effect? Tension lay in the uncertainty. Astronomers modeled 3 scenarios: the minimal case, where Atlas's coma barely intersected Mars's orbital path; the moderate case, where the dust tail showered the upper atmosphere in charged particles; and the extreme case, where fragmentation events could scatter debris across a wide swath of space, threatening orbiters and rovers alike. Each scenario came with its own probabilities, none reassuring enough to dismiss. The problem was compounded by the paradox of the coma itself. With the nucleus hidden, no one could say how stable Atlas truly was. If it shed material in sudden bursts, as comets often did, the geometry could shift, magnifying risks. The memory of Comet Siding Spring's close pass in 2014 loomed large. Then, Mars had been bathed in a storm of plasma as a comet skimmed past, forcing orbiters to take evasive maneuvers. Atlas, with its far larger coma and stranger chemistry, promised an encounter even more dramatic. The comparison made scientists restless. They did not expect catastrophe, but they knew better than to ignore precedent. The crossing geometry was not only a calculation, it was a moment of suspense, a cosmic alignment that demanded vigilance. And as February nights ticked away, telescopes and satellites alike braced for the approach, their eyes fixed on the green storm hurtling toward the orbit of Mars. The closer Atlas drew to the Martian corridor, the sharper the debate became. Researchers began speaking less in abstract probabilities and more in concrete scenarios, as though rehearsing outcomes for a drama no one could yet script. The best-case scenario was almost poetic. Atlas would glide past at its calculated distance, its coma brushing the thin Martian atmosphere just enough to ignite transient auroras. Cameras aboard orbiters would capture sheets of emerald light shimmering over the planet's rust-red horizon, a spectacle never before witnessed. For rover teams on the surface, the event would be invisible to the naked eye, but momentous nonetheless, a chance to measure atmospheric changes, to record subtle ripples in plasma fields. In this version of the future, Atlas would pass as a luminous visitor, leaving behind data and beauty but no scars. But alongside that vision lay a darker path. The worst-case scenario carried the weight of precedent. Siding Spring's flyby in 2014 had already forced orbiters to shelter, their instruments turned away to avoid damage from dust impacts. Atlas's coma, however, was orders of magnitude larger, denser, and more unpredictable. If a burst of fragmentation occurred during its crossing, millions of microparticles could sweep across the Martian orbital zone at lethal speeds. For fragile satellites, even grains the size of sand could strike with the force of bullets, shredding solar panels or puncturing radiators. A cascade of failures was unlikely but not impossible. Engineers whispered nervously about domino effects that could cripple Mars's communications network in hours. On the surface, rovers might ride out the storm unharmed, yet their data feeds could fall silent if orbiters above them faltered. The image of robots waiting wordlessly under an alien sky while their lifelines blinked out became a chilling refrain. Between these extremes lies the most probable scenario: moderate disruption. Here, Atlas's particles would skim Mars's upper atmosphere, generating a plasma storm that might temporarily scramble electronics or distort telemetry. Satellites could recover, but not without tension. Even this middle path carried consequences: days of interrupted data, precious instruments at risk, the possibility of lost experiments. For mission planners who had poured decades into Mars exploration, even a temporary blackout felt heavy. What amplified the tension was the sheer unpredictability. With Atlas's nucleus still unseen, models had to rely on coma behavior alone, and coma behavior was precisely what refused to conform. Some nights it swelled, other nights it dimmed, like a living thing with moods. Would it hold steady during the crossing, or erupt without warning? That uncertainty transformed every planning session into a balancing act between hope and dread. No one wanted to overstate danger, yet no one wanted to be caught unprepared. For the wider public, the narrative played out like a cosmic thriller. News anchors explained the best versus worst framework with glowing graphics. Mars wrapped in auroras on one side of the screen, orbiters torn apart on the other. Hashtags trended number Martian storm, number Atlas crossing, as people speculated whether humanity's robot ambassadors would survive their trial. The tone was not panic, but suspense. It was the tension of watching storm forecasts and wondering if the hurricane would veer or strike. Atlas had become a storm not of clouds and wind, but of dust, plasma, and possibility. And as the days to closest approach dwindled, the entire world leaned forward, waiting to see whether Mars would greet its emerald visitor with awe or with scars. As February 2026 reached its midpoint, the geometry tightened like a drawn bowstring. The comet's emerald veil now filled telescope frames so completely that Mars itself seemed a dim ember beside it. Observatories released predictive visualizations showing the planet enveloped in a passing cloud, a delicate dance between two worlds that might unfold over hours but carry consequences for years. Every update sharpened the tension. The crossing date, February 18th, was circled in red across calendars from Pasadena to Paris. It was not doomsday that people anticipated, but a kind of cosmic reckoning, a test of how well humanity could read the sky when the sky refused to play by its own rules. The final models told a story of edges. If Atlas held its current trajectory and remained stable, Mars would experience a grazing touch, a brush of plasma storms, a flicker of auroral curtains, perhaps a rain of dust too thin to harm. Yet if instability struck, if the hidden nucleus fractured, if jets erupted suddenly, geometry could bend. The tail could widen, the debris spread, and the red planet's orbital zone could become a gauntlet of shrapnel. Engineers began issuing quiet advisories, moving satellites into safer orientations, and preparing contingency protocols. Teams spoke in clipped voices, balancing confidence with caution. No one wanted to utter the word failure, but everyone felt its shadow. In homes across Earth, curiosity deepened into fascination. Live streams promised real-time coverage, showing Mars as a tiny disk awaiting its encounter. Commentators compared it to watching an eclipse, except this time the alignment involved not Earth and Moon, but two wanderers meeting in the silence of interplanetary space. Schools organized viewing events, turning the crossing into a teachable moment about probability, risk, and resilience. Yet beneath the educational tone ran the same undercurrent felt by scientists: suspense. It was the kind of suspense that gnaws quietly, not because catastrophe is certain, but because uncertainty itself is the storm. The rovers on Mars became unlikely protagonists in the unfolding drama. Perseverance, curiosity, the silent relics of opportunity and spirit, all were invoked in stories as though they were sentinels awaiting the visitor. Journalists wrote of their cameras pointed skyward, their instruments humming in expectation, though in truth they would see little beyond shifting plasma fields. Still, the narrative stuck. The machines we had sent to another world were about to share in the suspense, standing under the same green shadow as their makers millions of kilometers away. For many, it was a reminder that exploration was never detached from vulnerability. Even our most advanced creations could be humbled by a dust storm born in another star's nursery. On the eve of closest approach, the world seemed to hold its breath. Data centers prepared for overload as millions tuned in, waiting for confirmation of which path reality would choose. Would Mars's skies ignite in emerald curtains of harmless beauty, or would reports of damaged satellites flash across the wires? No one could say. That silence, the silence of not yet knowing, became its own presence, heavy as the emerald coma itself. Atlas had once again forced humanity into a posture both ancient and modern. Eyes lifted in awe, hearts suspended in unease, minds racing ahead with what-if calculations. And so the Mars-crossing geometry resolved not into certainty, but into a tension that gripped the globe. The visitor had not yet spoken, the dice had not yet landed. All that remained was to watch, to measure, to wait. For in the vacuum of space, suspense stretches long, and the only forecast left is the one written in the green fire of a comet that refuses to play by the rules. By the final week of February 2026, Atlas was no longer merely a cometary enigma. It had become a pilgrim edging toward fire. Its orbit had bent it into a perilous path sunward, drawing it inexorably toward the place where even light seems to burn with hostility. The sun, a constant presence in humanity's skies, had always been both a source of life and a symbol of destruction. Now it became the stage for a drama that no one could look away from. Cameras aboard solar observatories caught the moment. Atlas, haloed in emerald mist, approaching the corona. Against the blinding blaze of a star that dwarfs Earth by a millionfold, the comet should have been swallowed whole. And yet, it was not. It glowed defiantly, a green spark holding its shape in the furnace, as if daring the sun to erase it. Astronomers described the mechanics with cautious clarity. Nearing perihelion, its closest pass, Atlas endured temperatures that vaporized its icy surface almost instantly. Water turned to vapor, carbon dioxide to gas. Volatile compounds erupted in furious jets. Each eruption fed the coma, already monstrous in size, until the halo became a storm that dwarfed planets. The solar wind, a relentless stream of charged particles moving outward at hundreds of kilometers per second, collided violently with this material. The impact sculpted Atlas's veil into sweeping tails, ribbons of green fire dragged outward into the solar gale. Equations mapped the behavior, simulations explained the dynamics, yet the images told a deeper truth. The comet no longer looked like a lump of rock and ice. It resembled a living thing caught in agony and radiance, enduring a trial by fire. The spectacle provoked awe and dread in equal measure. Commentators compared it to a moth drawn toward flame, or a sacrificial offering thrown into the hearth of creation. Historians of astronomy reminded viewers of Comet Ison in 2013, which had rushed with similar boldness into the sun's arms, only to shatter and vanish in less than a day. Would Atlas share this fate, or would it, impossibly, survive? No one could answer. The sun, in its indifference, gave no hint. It burned with the same terrible serenity as it had for billions of years. Atlas, emerald and unyielding, carried its mystery closer, closer still, toward that crucible. For the public, the sight carried a resonance deeper than data. Humans had always feared and revered the sun, worshipping it as a god, fearing it as a tyrant. To see Atlas fling itself into that inferno was to witness mortality enacted on a cosmic scale. If the comet perished, it would be no surprise. Another wanderer consumed by the fire that feeds all. Yet if it endured, the meaning would be stranger, even haunting. Survival would turn it into a symbol, not of fragility, but of defiance, a messenger from interstellar dark that could endure the touch of a star. Either path, death, or endurance seemed extraordinary, a revelation written not in words but in fire and emerald light. What unsettled observers most was the beauty. The sun's corona flared in golden arcs, while Atlas's tail whipped like a green banner through the storm. Photographs looked unreal, like paintings born of myth, yet they were real, captured by satellites and ground-based filters. In them, Atlas was no longer just an object. It was a vision, something sublime and terrifying. People stared at the images and felt their breath shorten. It was beauty that hurt, beauty edged with fear. It was a reminder that the same sun that warmed their skin was also capable of destroying worlds without effort. And in that juxtaposition, life and death, radiance and ruin, Atlas carved its place as more than a comet. It became an icon, a mirror, a riddle blazing against the most powerful fire humanity knows. It began not with a whisper, but with a blinding surge of data. On the morning of the 29th of September 2025, every major observatory across the world registered something no algorithm had predicted. 3. Divided by Atlas, the interstellar wanderer, already unsettling astronomers with its alien trajectory, had erupted into sudden brilliance. In a matter of hours, its apparent size in our instruments more than doubled, its coma swelling like a green-haloed wound tearing open against the dark canvas of space. What had been a faint, ghostly visitor became a spectacle that dominated the feeds of NASA, ESA, and amateur skywatchers scattered from Chile's Atacama Desert to the frozen ridges of Mauna Kea. The shock was not confined to datasheets. It rippled through newsrooms, lit up message boards, and ignited an undercurrent of unease. Humanity had been watching this comet-like intruder for months, believing it was predictable, containable within the neat lines of orbital mechanics. Now, overnight, it had defied those lines. The initial reports were clinical. Spectrographs showed spikes in green frequencies, coma density estimates escalated beyond projections, and solar wind interactions intensified. But the language of scientists quickly gave way to the language of disbelief. Words like unprecedented, alarming, and inexplicable crept into the official statements. A special bulletin was released jointly by NASA and ESA, not to declare danger, but to admit ignorance. That, in itself, was the earthquake. The world is accustomed to hearing scientists speak with careful certainty, even when uncertainty lingers beneath. To hear them confess openly, "We do not understand why Atlas has grown so rapidly, or what this expansion implies," was to feel a crack open beneath the foundation of rational trust. The announcement did not soothe it unsettled. Cameras followed trembling voices. In the control room of the European Southern Observatory, technicians who had tracked supernovae and black hole shadows now stared at screens as if watching a nightmare bloom. The coma of 3I divided by Atlas pulsed with a brightness that seemed alive, an emerald sphere swelling and reshaping like a living organism expanding its chest. "It looks wrong," whispered one researcher off mic, and the phrase leaked into the social networks within minutes, spreading faster than any official clarification. Wrong. Not extraordinary. Not beautiful. Wrong. That single adjective carried the emotional payload of the shockwave. People had stared at comet tails before, marveled at Hale-Bopp, or traced Oumuamua's eerie sliver across the night sky. But this was not awe mixed with delight. This was awe tangled with dread, a sense that something had just slipped out of our hands. News outlets framed the event with the urgency of disaster reporting. Banners scrolled in crimson across television screens. 3I divided by Atlas expands unexpectedly. Scientists baffled. On social media, images spread like wildfire. Jagged graphs, spectral spikes, composite visuals of the coma now dwarfing earlier estimates. The green glow was not static. It flickered, as though the object were signaling or struggling, breathing against the vacuum. For every cautious explanation offered that volatile gases had suddenly sublimated, that solar heating had reached a tipping point, 10 voices were whispering more unnerving theories. Was this thing breaking apart? Was it hiding something inside? Was it not a comet at all? The shockwave did not end with astonishment. It deepened into the quiet disorientation of not knowing what came next. Scientists thrive on questions, but the public thrives on answers, and for once, the supply had run dry. The first press conference ended with silence rather than reassurance. A question hung in the air like static. If it could double overnight, what else could it do tomorrow? No graph could soothe that dread. No calm voice could erase it. 3I divided by Atlas had become not just an astronomical object but a psychological event, a mirror reflecting the fragility of human certainty. The world had awakened to a new reality, that the cosmos was capable of ambushing us, even in an age when we believed the sky had no secrets left to surprise us. The shockwave, once unleashed, refused to settle. Within 24 hours of the announcement, observatories across the world were no longer just collecting data, they were scrambling to reframe their entire approach. Telescope time, once reserved for exoplanet surveys, galactic mapping, or black hole dynamics, was abruptly reallocated. Everything, it seemed, had to bend toward this swelling interstellar trespasser. Astronomers who had spent careers in niche specializations found themselves pulled into emergency coalitions. "Drop what you're doing, point everything at Atlas," became the unspoken command whispered through late-night calls and hurried memos. The expansion of the coma was not slowing. In fact, fresh readings suggested it had accelerated again. The green halo had thickened into a translucent cocoon stretching tens of thousands of kilometers wider than expected. Its brightness on magnitude scales leapt upward, putting it in competition with planets on the night sky. For casual stargazers, it meant they could now see with their naked eyes what scientists had thought would remain faint. For professionals, it meant their models were collapsing in real time. The tone of conversation shifted quickly from surprise to unease. The familiar vocabulary of cometary behavior, outgassing, sublimation, dust jets, no longer seemed sufficient. If such processes were responsible, why had no other comet in recorded history behaved with this ferocity? Why had none erupted into such monstrous scale within a single solar week? Some analysts whispered comparisons to Oumuamua, that strange, elongated visitor from 2017, whose acceleration could not be neatly explained by gravity alone. But where Oumuamua had been a riddle written in subtle signals, Atlas was an explosion of visibility, a riddle that shouted instead of whispered. The sheer audacity of its growth made it impossible to look away, and as the object commanded every lens, every sensor, every article headline, a darker current began to spread. Perhaps this was not an expansion in the way humans understood expansion. Perhaps what we were seeing was a reveal, a veil falling, a shell opening. Such ideas were not voiced in official reports, of course. Agencies clung to restraint, offering conservative phrases like anomalous behavior, significant deviation, and pending review. Yet restraint could not contain the human imagination. On forums, in podcasts, and across late-night talk shows, speculation roared. Was Atlas harboring a massive icy core whose gases had only now been unleashed? Was there some unknown chemistry at play, producing emissions Earth had never catalogued? Or more unsettling still, was it an entirely different class of object masquerading as a comet until now? The very act of questioning this tore at the fabric of certainty. The cosmos had once again reminded humanity that our categories were brittle, provisional, subject to shattering with a single, unexpected observation. Media outlets capitalized on the mood, their cameras panning across crowded rooftops where amateurs pointed binoculars skyward, their faces lit with the same green glow that haunted professional data streams. Children asked their parents if the bright emerald star was dangerous. Politicians stumbled when asked on air whether governments had contingency plans for interstellar threats. Conspiracy channels flourished, weaving tales of secret knowledge suppressed by space agencies. The public, left with more questions than answers, slipped toward unease. What rattled them most was not the prospect of impact trajectories, remained clear of Earth, but the raw uncertainty of scale. If something could inflate itself to twice its visible size in less than a week, what guarantee existed that it would not alter course, alter form, or alter the physics that underpinned all predictions? Inside control rooms, silence became the dominant language. Scientists accustomed to animated debate now sat staring, fingers tapping nervously against metal consoles. In the glow of monitors, they were not just seeing data, they were seeing the collapse of assumptions, the fraying of trust in their models. The phrases that echoed were not equations but confessions. We didn't think it could do this. We don't know what drives it. We cannot predict what comes next. Each confession carried weight, and with it, a subtle fear that the public would misinterpret honesty as incompetence. Yet honesty was unavoidable. The spectacle of Atlas had outpaced every explanatory framework. It had become, in less than 48 hours, a symbol of our vulnerability to the unknown. By the end of the week, the object's image had replaced weather maps on news stations. The emerald cloud dominated the backgrounds of broadcast anchors, its eerie hue becoming a collective backdrop to human conversation. Ordinary people described dreams haunted by the color, by a sense that the sky itself was infected with strangeness. Psychologists began to remark on a new phenomenon, comet anxiety syndrome, a collective unease, driven not by threat of collision, but by the feeling of living under something vast, unpredictable, and indifferent. In coffee shops, in subways, in online streams, people asked one another, "What is that thing really?" The question lingered like static, unanswered, unanswerable. The days that followed turned into a surreal theatre of vigilance. Atlas did not recede into quiet obscurity. It continued to dominate both sky and psyche. Every night, millions of eyes sought it, some out of wonder, others out of dread. Its swollen green aura became a fixture in the heavens, a spectral lantern whose presence no one could ignore. Amateur astronomers reported that their telescopes revealed not just a glow but shifting textures, as if layers of translucent curtains were peeling back from an unseen stage. Professionals verified the turbulence, density fluctuations, irregular jets, streaks of light that flickered and died in intervals too structured to dismiss as random noise. The more instruments captured, the less the world felt in control. Atlas had transformed from an object of study into an actor on the cosmic stage, unpredictable and unwilling to be scripted by human expectation. Governments attempted to calm the rising unease. Officials repeated the refrain, "No trajectory intersects Earth, no direct danger is anticipated." Yet the reassurances rang hollow. People were not afraid of impact, they were afraid of not knowing what they were witnessing. The green cocoon in the sky symbolized something larger, the fragility of our scientific maps, the reminder that nature could still conjure phenomena that slipped entirely through the nets of prediction. Each press conference, with its polished graphics and measured tones, failed to erase the underlying tremor of collective anxiety. Journalists pressed harder, their questions circling the same unspoken dread. If Atlas could expand so violently, what limits existed on its behavior? And if limits were unknown, what did that say about humanity's presumed mastery of cosmic knowledge? As tension grew, so did fascination. Sales of backyard telescopes surged, downloads of star-tracking apps spiked, and live streams of the object drew audiences in the millions. What was once a niche corner of astrophysics had bled into mainstream culture, entwining science with spectacle. Artists painted Atlas as a green leviathan devouring the night. Poets wrote of it as a wound in the sky. Musicians sampled its spectral spikes into eerie soundscapes. The comet had become more than matter and gas. It had become myth in real time. But not a comforting myth. A myth edged with unease, whispering that the universe was not finished, surprising us, not finished, reminding us of our smallness. The most unsettling detail came in the second week, when high-resolution imagery hinted at a curious geometry within the coma. Buried in the fluctuating haze was a darker shape, elongated, asymmetrical, stubbornly resistant to modeling. Some insisted it was an artifact of imaging. Others suggested it was simply denser material ejected in irregular streams. Yet once the images leaked to public channels, speculation ignited like wildfire. Memes circulated portraying the dark form as a vessel, as a shard, as something hidden emerging at last. Scientists bristled at such dramatization, but in private, some admitted that they, too, saw patterns they could not yet explain. The human brain, so skilled at finding shapes in clouds, could not resist projecting meaning onto the emerald storm. And whether artifact or anomaly, the perception deepened the unease. Atlas was not merely expanding, it was revealing. At night, talk show hosts asked their audiences if they felt safe sleeping under that strange green star. Polls suggested a startling truth. While only a minority feared physical harm, a vast majority confessed to a sense of existential vulnerability. Words like restless, haunted, and unmoored appeared in surveys, as if Atlas had unsettled not just the sky, but the ground of human identity. Children drew it in classrooms. Adults whispered about it in hushed tones. The object had become part of daily life, woven into dreams and worries alike, and with each passing hour, it demanded more attention, more interpretation, more surrender of certainty. By the close of September, the shockwave that began with a single announcement had swelled into a global mood. Atlas had not struck Earth, nor had it rained destruction from above. Yet it had done something subtler, perhaps more profound. It had destabilized the collective narrative of predictability. The cosmos had always been vast and mysterious, but humanity had lulled itself into believing that with enough sensors, satellites, and simulations, the unknown could be tamed. Now, a visitor from the interstellar deep had torn through that illusion in the simplest of ways, by growing larger than it was supposed to, by defying categories with a green shimmer, and so the world looked up, night after night, with a mixture of fascination and dread. The question was no longer simply, what is it? The question had become more intimate, more unsettling. What does it mean for us that something so close, so visible, can remain so utterly outside our understanding? By the first week of October 2025, the shockwave of Atlas's sudden expansion had begun to settle into a quieter, stranger reality. The comet's emerald bloom still dominated telescopes, still haunted the night sky with its swollen presence. But behind the brightness came something far more unsettling: silence. In every spectrum where astronomers expected chatter radio emissions, microwave whispers, X-ray echoes, there was only absence. Atlas shone with the brilliance of a green beacon, yet it refused to speak. The paradox loomed larger with each passing night, a giant that illuminated the heavens while offering no signature, no sound, no trace of the noisy physics that should accompany such a display. At Jodrell Bank in the United Kingdom, the great radio dish tilted patiently toward the visitor. The antennas hummed as they swept across bands where cometary activity usually roared like static storms, but the recordings came back flat, eerily featureless. "It's like tuning into a dead channel," one engineer muttered, his voice carrying in the cavernous control hall. Across the Atlantic, the Very Large Array echoed the same result. No jets of molecules, no collision sparks, no hiss of ionized tails meeting solar winds. In Hawaii, the infrared sensors at Mauna Kea found warmth. Yes, but no fluctuations, just a cold steadiness that felt incompatible with the violent growth observed in visible light. The silence was not accidental, it was systemic. Atlas was holding something back. Scientists are not strangers to anomalies. Data can be corrupted, instruments can misfire, and cosmic rays can trick detectors. And so the first instinct was caution, to doubt the tools rather than the sky. But the pattern repeated across continents, across technologies, across independent teams that did not share protocols or equipment. There was no escaping the conclusion. The silence belonged to Atlas itself. It was a silence not of absence, but of deliberate withholding, as if the object had chosen to shine without speaking. The scale of it provoked an unease deeper than any statistical anomaly. For light dazzles, but silence unnerves. It is the quiet that unsettles armies before a storm, the pause of breath before the scream. Humanity stared at Atlas and felt that pause stretch into infinity. What made the paradox sharper was memory. Those who had studied Borisov in 2019 remembered the rush of data jets spewing signatures of carbon monoxide, bursts of hydrogen cyanide, familiar if exotic chemistry. Those who had puzzled over Oumuamua in 2017 remembered the strange acceleration, yes, but also the chatter of reflected spectra, the evidence that it interacted robustly with the sun's light. By contrast, Atlas seemed like a performance stripped of soundtrack, a glowing apparition moving across the solar stage with mute defiance. A silent giant. The phrase first appeared in a late-night forum, typed by an amateur in Poland watching the green coma through backyard glass. By dawn, the phrase had spread through headlines, echoed by journalists who felt the same unease scientists could not yet articulate. The words stuck because they were true. Atlas was vast, luminous, impossible to ignore, and utterly unwilling to make a sound. The hoarse quiet of Atlas began to fracture confidence inside laboratories. Each day, more observatories confirmed the same finding: dazzling brightness in the visual spectrum, absolute refusal to register anywhere else. It was as if the comet had chosen to perform for human eyes alone, while every other instrument was blindfolded. Teams at NASA's Goddard Space Flight Center tried layering composite readings from ultraviolet to submillimeter ranges, desperate to stitch together some faint murmur in the background. Nothing. The graphs remained barren, a blank sheet where chaos should have painted strokes. It glows like a city seen from orbit, one astrophysicist remarked, yet it hums less than a candle. The comparison spread through hallways like an unwanted mantra, a reminder that brilliance without voice was more terrifying than darkness itself. The unease sharpened into suspicion. Was the silence an illusion born of human limitation, or was it intrinsic to Atlas? Engineers recalibrated sensors, ran simulations, even pointed equipment at known comets to confirm their ears still worked. The contrast was brutal. Ordinary comets screamed in data, their tails alive with signatures of volatile elements, their interactions with solar winds producing static-filled symphonies. Then telescopes swung back to Atlas, and once again the channel fell quiet. Some began to whisper that the object was absorbing frequencies, swallowing the very signals it should emit. The idea was half science, half nightmare, an object that not only refused to speak but actively suppressed its voice. In the solitude of control rooms, the silence took on a presence, a weight. The longer they stared at flat graphs, the more they felt the silence staring back. Public audiences, fed by leaks and speculation, grew restless. Forums debated whether Atlas was cloaked by exotic materials, masking its spectrum deliberately. Some commentators drew comparisons to stealth aircraft, machines built not to be invisible, but to silence the frequencies by which they could be tracked. Scientists dismissed such analogies in official channels, yet privately admitted the metaphor was hard to shake. How could something so massive, so radiant, fail to leave fingerprints across the full electromagnetic range? How could a body tens of kilometers across remain acoustically void? Skepticism metastasized into paranoia. Was Atlas truly a natural body at all? Or was humanity, for the first time, confronting a phenomenon designed to remain quiet? The irony deepened when agencies released high-definition photographs. The images were exquisite, veils of green gas curling like auroras, sharp edges of jets frozen against the backdrop of stars. They were art, breathtaking enough to make headlines without a scientific context. Yet for those who understood what was missing, the beauty felt menacing. A comet that paints the sky so vividly should chatter like fire. Instead, Atlas's gallery of images felt like postcards from a mute giant, proof of presence without explanation. "We are drowning in visuals and starving for sound," lamented one researcher, echoing the despair of colleagues worldwide. The public admired the green lantern. The scientists feared the silence beneath. By mid-October, hoax theories found fertile ground. Videos claimed the silence proved alien origin, that Atlas was no comet but a vessel, its luminous shroud a manufactured disguise. Governments scrambled to counter with calm explanations, but the absence of concrete data left them vulnerable. Even rational minds could not dismiss the strangeness. The silence was not benign. It was accusatory, provoking questions that science was unprepared to answer. What if Atlas were not malfunctioning but behaving exactly as intended? What if its silence was its message? By late October 2025, the silence of Atlas had ceased to feel like a gap in data and instead hardened into a presence of its own. It was no longer framed simply as an absence of sound. It was experienced as an active phenomenon, a quality that weighed on those who studied it. In laboratories and control rooms, the atmosphere grew uncanny. Screens filled with radiant green imagery, yet monitors that should have pulsed with signals remained inert, glowing with the emptiness of flat lines. Scientists confessed, in private notes and unrecorded conversations, that they began to feel as though the silence itself was speaking an anti-message, a negation that carried weight equal to any measurable emission. The paradox was unbearable. Atlas appeared immense, vibrant, almost alive, yet it sat cloaked in a refusal that bordered on defiance. Philosophers and cultural critics entered the conversation. They compared the silence of Atlas to the great silence of the cosmos, the riddle of why, in a universe filled with stars, humanity has yet to hear voices from elsewhere. Now, that silence had a form, a face emerald, swollen, undeniable. It was as though the enigma of the entire galaxy had condensed itself into one traveler and stationed it within our neighborhood of the Sunday. Atlas became a metaphor for the limitations of human perception, for the fragility of our instruments, for the arrogance of assuming the universe would always communicate on terms we understood. The comet was no longer just a body of ice and dust. It had become a mirror, reflecting our need for answers, and the terrifying possibility that answers might never come. This philosophical weight bled into daily life. Journalists wrote features describing sleepless nights among astronomers who stared at blank graphs until dawn. Therapists reported a rise in patients confessing unease, not from fear of collision but from the deeper dread of confronting a mystery that offered no dialogue. The term silent giant syndrome began to circulate, an anxiety disorder triggered by the juxtaposition of overwhelming presence and absolute quiet. Some likened it to standing in a cathedral where the organ pipes glowed but refused to sound, leaving worshippers crushed under the weight of expectation unmet. The sky itself had become a cathedral, Atlas, its mute altar. Speculation multiplied, and with it, hoaxes thrived. Yet beyond the noise, serious scientists confronted darker hypotheses. Could Atlas's silence indicate new physics mechanisms of light emission decoupled from spectral chatter? Could its material be unlike anything in known cometary families, tuned in such a way that energy was released in visible bands but strangled elsewhere? These were possibilities, but none felt satisfying. Every model collapsed under the enormity of what was missing. To explain silence, one had to first assume there was something to explain, and Atlas, with its vast green shroud, offered no concession. The deeper scientists probed, the more personal the mystery became. People spoke of dreams filled with emerald haze, of hearing silence as though it were a tone, an unvoiced frequency pressing against their skin. Some admitted to feeling watched. Rationally, they knew Atlas was simply reflecting sunlight in peculiar ways. Emotionally, they could not escape the sense that the object was performing, choosing to shine, choosing not to speak. In that choice, they saw intent, whether natural or otherwise, and in intent, they saw something alien to human comfort. As October gave way to November, the phrase silent giant was no longer just a label. It was a diagnosis of our relationship with the unknown. Humanity had always sought meaning in cosmic events, shooting stars, eclipses, supernovae, but never had a spectacle been accompanied by such a deliberate quiet. Atlas hung above like a monument carved out of contradiction, bright yet mute, vast yet withholding, near enough to dominate our skies, yet remote enough to evade our understanding. The silence pressed like a weight on the world's collective chest, and beneath that pressure, suspicion hardened into a darker realization. Perhaps Atlas was not waiting to speak at all. Perhaps its silence was the only message it would ever give. By early November 2025, the silence of Atlas had pressed heavily on the world, but in its shadow another force began to rise, a determination to listen harder, to look closer, to stand together beneath the mystery. Scientists who had once competed for telescope time now began to share it, opening their calendars and their data streams to colleagues across borders. What emerged was not simply a collaboration, but a network, an improvised lattice of intellect and technology that stretched across continents. They began to call it, almost poetically, the global eye. The eye blinked awake first in the deserts of Chile, where the Atacama's thin skies offered some of the sharpest views of the green intruder. Giant mirrors tilted toward Atlas, capturing photons that had traveled millions of years before bouncing from its swollen coma. Those images were transmitted within seconds to supercomputers in Europe, where algorithms processed them and pushed them onward through encrypted channels to labs in Asia. From South Africa's plateau to Australia's interior, from radio dishes in Canada to optical telescopes in Japan, the same rhythm repeated. Data left one hemisphere and appeared in another almost as fast as the comet's own expansion. It was as if humanity had woven a nervous system around the globe, each node pulsing with the same green signal. The breakthrough was not technical, it was cultural. For decades, science had been fractured by boundaries. Who owned the telescope? Who published first? Who claimed the discovery? Atlas silenced those rivalries. In its silence, people found a different kind of voice. The recognition that no one nation could own this phenomenon, and that only together could they hope to map its strangeness. Agencies that once guarded their archives through open access. NASA released real-time feeds of raw data to counterparts in China and India. Amateur astronomers, once dismissed at the margins, were invited into shared databases, their backyard readings adding texture to the professional models. "Every eye matters" became the unofficial slogan of the project. For the first time in living memory, science felt less like a battlefield and more like a choir. Each instrument, no matter how humble, contributed a note to the collective song. A child with a modest telescope in Argentina might notice a flicker that confirmed a pattern seen by a billion-dollar facility in California. A retired engineer in Kenya, armed with a self-built spectrometer, might flag a detail that filled a gap left by weather-obscured observatories in Europe. The eye was not just global in reach, it was democratic in spirit, and in that shared gaze, there flickered something humanity had nearly forgotten how to feel: cautious hope. For though Atlas remained mute, though it defied the categories of known science, the act of watching together brought a measure of calm. In the face of its silence, humanity had answered with connection. What one person could not understand, perhaps 1,000 could, and what 1,000 could not solve, perhaps 1,000,000 would glimpse by sheer accumulation of detail. The mystery remained, vast and unbroken, but against it now pressed the weight of collective attention. Atlas had become the great exam, the shared riddle, and for the first time in a generation, the world seemed willing to face the riddle not as fractured nations, but as a species united by a common sky. The global eye did not exist on paper. It existed in the pulse of fiber-optic cables, in satellite relays, in the crowded chat windows where scientists exchanged raw impressions at 3 a.m. A new rhythm emerged, the handoff of night from one hemisphere to another. As dawn rose in Chile, telescopes in South Africa were already taking over, and when clouds rolled across Tokyo, the skies above Hawaii were just clearing. The world became a chain of vigilance. A baton passed endlessly around the planet so that Atlas was never left unobserved. Sleep became a luxury few could afford. Graduate students hunched over keyboards in Mexico, traded files with professors in Moscow. Retired astronomers in New Zealand uploaded their readings into shared repositories, where AI tools stitched them into mosaics of unprecedented clarity. For those participating, it felt like living inside a single global observatory, walls stretched thin across oceans, its heartbeat steady in the flow of data packets. There were moments of exhaustion, yes, but also of quiet exhilaration. Many confessed later that they had never before felt so close to strangers thousands of miles away. A researcher in Munich would type a note of frustration, still no radio spikes, still silence, and within minutes receive encouragement from colleagues in Cape Town or Bangalore. Across accents and languages, there was an intimacy born of shared staring, shared not knowing. The comet had refused to speak, but it had given humanity the gift of speaking more openly to each other. Amateurs, too, discovered a newfound dignity. Where once their work was often relegated to footnotes, now their observations were treated as vital threads in the tapestry. In rural Brazil, an astronomy club of teenagers pooled their modest equipment and sent nightly updates. To their astonishment, one of their graphs, a crude time-lapse of brightness fluctuations, was flagged by an international team as corroborating evidence for a subtle variation missed by larger instruments. The story spread online like a parable, proof that the eye was truly collective, that no perspective was too small to matter. Every eye counts, The phrase repeated across social networks, painted on posters, and even turned into a trending hashtag. And beyond the technical triumphs, there was a moral one. Humanity had been fractured by distrust, scarred by competition, and wearied by crises. Yet here, beneath the green haze of Atlas, there was a fragile truce. Nations that rarely shared intelligence found themselves sending data packets within seconds of capture. Institutions that had once fought for funding now funneled resources into joint archives. For all the suspicion that lingered in geopolitics, the comet had forced a new logic. No one could face it alone. Against the backdrop of Atlas's silence, unity was the only viable experiment. This unity carried with it a kind of fragile hope. Nobody claimed that answers were around the corner. The silence persisted, mocking every effort to decode it. But the act of listening together began to feel like an answer in itself. In hushed conference calls, leaders of the network spoke not of triumph, but of perseverance. "We may not understand Atlas today, or tomorrow," one scientist remarked during a streamed symposium, "but we are building the capacity to face it together." The audience, drawn from dozens of countries, fell into rare applause. It was not applause for discovery, it was applause for connection. The green star in the sky had not yielded its secrets, but it had given humanity a different kind of treasure, a fleeting glimpse of itself as one organism, one mind, one eye stretched across the globe. The echoes of Atlas grew loudest, not in laboratories but in conference halls. In mid-June 2026, the United Nations convened an emergency but carefully worded session under the banner of planetary preparedness. Delegates from more than 40 nations sat in hushed chambers, while scientists presented data anomalies, uncertainties, near-miss probabilities. No alarms were sounded, but the atmosphere was taut. The comet had not threatened Earth directly, yet its swarm signals, plasma storms, and unpredictable behavior had forced a new calculus. Humanity could no longer treat such events as rare curiosities. They were rehearsals. The session unfolded with an air of pragmatic suspense. NASA officials pushed for expanded funding for planetary defense programs, citing Atlas as the proof of concept that interstellar bodies were not hypothetical. ESA proposed joint missions to build interception probes, arguing that no single nation could respond quickly enough alone. Smaller countries, lacking resources but not vulnerability, demanded inclusion in data-sharing agreements. The mood was not combative but tense, each statement layered with the weight of responsibility. The comet had united the world, but it had also revealed fractures, questions of who would pay, who would lead, who would act first when the next Emerald Wanderer appeared. Scientists amplified the urgency with carefully chosen words. They spoke not of doomsday, but of probabilities, of risk curves bending in ways the public could not see. They reminded the Assembly that Comet Shoemaker-Levy 9 had scarred Jupiter in 1994, leaving wounds larger than Earth itself. Atlas, with its dense coma and swarm-like whispers, could have written similar scars on a different canvas had geometry shifted slightly. The implication was clear. Preparedness was not paranoia, it was prudence. The echoes spread beyond politics into culture. Think tanks in Washington, Paris, and Beijing published white papers with titles like From Spectacle to Strategy and the Economics of the Next Visitor. Universities introduced courses blending astrophysics with risk management, training a generation to think in both equations and contingencies. Even the language of the press began to change. Where once headlines had celebrated Atlas's beauty, now they framed it as a wake-up comet, a reminder that awe and caution were inseparable. For ordinary citizens, the effect was subtle but real. Public polls revealed a surprising willingness to fund space monitoring programs, even in nations facing domestic struggles. People who had watched Atlas's emerald fire from their screens felt personally invested in the idea that the next one might matter more. It was a rare alignment of wonder and practicality. Awe had translated into policy support. The comet had not only lit the skies, it had lit a fuse under the machinery of human cooperation. And yet, under the applause and resolutions, uncertainty still pulsed. Everyone agreed Atlas had been a warning, but no one agreed on how large the warning should loom. That tension, that blend of conviction and doubt was the true echo. It left the world on edge, not paralyzed, but waiting, braced for a future that felt less theoretical than before. By July 2026, the comet was little more than a fading mark in deep space, yet its Earthside echoes still reverberated with a steady pulse. Reports circulated, budgets were revised, and plans announced. A sense of progress filled headlines. New radar arrays approved, fast response probe designs, advance, global data sharing pact signed. On the surface, it seemed humanity had answered the challenge with resolve. But beneath the optimism, a quieter mood lingered, a pragmatic unease, the awareness that readiness is never absolute. Engineers spoke frankly about limitations. Even with expanded sensors, many interstellar bodies would remain invisible until dangerously close. Even with interception probes, response times would be measured in months, not days. And even with global cooperation, politics could still slow down decisions. Atlas had not been a catastrophe, but it had exposed how fragile Earth's defenses remained. The lesson was simple. Preparation reduced risk, but it did not erase it. That gap, the space between what was done and what could never be fully controlled, was where the suspense lived. In classrooms, this nuance became part of the teaching. Professors reminded students that science is not about certainty, but about narrowing uncertainty. They used Atlas as a case study in humility. A comet that dazzled, survived the sun, whispered of swarms, and defied full comprehension even after terabytes of data. The message was sobering yet empowering. Humanity could learn, adapt, prepare but never master. That realization, more than any budget line or treaty, was the comet's lasting echo. For the public, the feeling was harder to name. People did not walk the streets fearing the sky, but they carried a subtle shift in perspective. Atlas had left them with a dual truth. The universe is breathtakingly beautiful, and it is breathtakingly indifferent. That duality translated into a cautious respect, a willingness to support preparedness not out of panic but out of prudence. It was the kind of realism that builds storm shelters without expecting storms every day. And so Part 11 closed on a paradoxical note. Humanity had responded funding networks, drafting plans, teaching lessons, but the echo of suspense had not faded. Atlas had shown what was possible, and possibility could not be put back into silence. The emerald fire was gone from the skies, but its reflection lived on in data tables, in classrooms, in boardrooms, in quiet conversations about what might come next. The comet's earthside echo was neither fear nor comfort. It was vigilance, stretched thin between knowledge gained and mysteries unresolved. A reminder that the story was not over, that the sky could speak again at any time. By July 2026, when Atlas had long since slipped beyond naked eye visibility, the fever of speculation cooled into the steady rhythm of analysis. The scientists who had once spoken in urgent tones about comas, swarms, and solar encounters now shifted their focus to a quieter, more disciplined task, separating signal from noise. The process lacked the drama of emerald skies and plasma storms, yet it was here, in spreadsheets and cross-checked logs, that the comet's true legacy was being distilled. Astronomy, like all sciences, is haunted by noise. Every detector, every telescope, every algorithm carries imperfections. Thermal fluctuations in sensors, cosmic rays striking cameras, atmospheric interference bending starlight. To the untrained observer, noise can look uncannily like signal, a phantom dot on a radar plot, a flicker in brightness, a ghostly streak across an image. Atlas, with its overwhelming coma and unpredictable behavior, amplified this problem. Instruments strained to parse faint fragments from the blaze, often returning results that seemed contradictory. Was that secondary echo a fragment, or just an artifact of processing? Did the brightness dip mark a companion, or merely a gust of dust within the coma? The discipline required was methodical. Teams did not chase single observations, but demanded replication across stations, instruments, and nights. A radar blip in Japan meant little unless Chile confirmed it. A brightness anomaly in Hawaii was filed as tentative until South Africa recorded the same curve. The guiding principle was simple but uncompromising. Signal must survive scrutiny. Noise vanishes under repetition. This principle, hammered into generations of scientists, became the anchor that held inquiry steady amid the turbulence of Atlas's spectacle. There was precedent for this caution. In 1991, radio astronomers recorded a peculiar pulse that for days resembled an artificial signal until it was revealed to be interference from a nearby microwave oven. In the early 2000s, exoplanet hunters announced candidates that vanished when better telescopes rechecked the data. Even in 2017, Oumuamua's strange acceleration sparked debates that continue, with some anomalies still unresolved. The lesson was always the same. Excitement must bend to discipline. For every discovery that endures, dozens fade under the weight of repeated observation. Applied to Atlas, this discipline turned raw spectacle into durable knowledge. Teams catalogued thousands of candidate anomalies and, through weeks of cross-checks, eliminated the majority. What remained were patterns robust enough to call signals. The confirmation of ionized oxygen as the cause of its emerald glow, the measurements of its dust-to-plasma ratio, the evidence of subtle non-gravitational acceleration consistent with jetting. Other claims, the swarm, the opaque coma, the rhythmic pulses, remained unresolved, not because they were disproven, but because the data had not survived the crucible of repetition. In the world of science, the absence of proof was not proof of absence. It was, instead, a call for humility. For the public, this stage seemed anticlimactic. The emerald blaze was gone. What remained were numbers and caveats. Yet for scientists, this was the most satisfying phase of all. In the quiet parsing of signals and dismissal of noise, Atlas revealed its truest lesson: that wonder and rigor must walk hand in hand. The comet had dazzled eyes and unsettled imaginations, but in the end, its enduring value lay in how it trained humanity to remain calm before the unknown, disciplined before the uncertain. That discipline was not flashy, but it was lasting. And it was the discipline that would matter most when the next interstellar traveler appeared. By August 2026, the signal versus noise discipline had produced its final reports. They did not read like revelations, but like carefully balanced ledgers, columns of confirmed measurements, columns of discarded anomalies, columns marked inconclusive. To the media, the format seemed underwhelming. There were no grand declarations of discovery, no dramatic proofs of swarm companions or alien chemistry. Instead, the documents embodied what science, at its most honest, always delivers: clarity where possible, humility where necessary. Confirmed signals stood out with reassuring solidity. The emerald glow, once a source of poetic speculation, was traced to ionized oxygen with confidence. The dust plasma engine was documented in detail, its thrust measured, its effects on orbital shifts quantified. Non-gravitational accelerations, once puzzling, now fit within models refined by Atlas's data. These results formed the backbone of what would enter textbooks: the comet as a living demonstration of sublimation mechanics, plasma interactions, and the beauty of natural propulsion. They were the bricks of certainty laid upon the foundation of observation. But alongside them sat the columns of unresolved echoes. The swarm hypothesis, despite months of scrutiny, could neither be confirmed nor fully dismissed. Radar anomalies remained tantalizing but inconsistent. Rhythmic pulses in brightness data defied clean categorization. In a discipline that demands repetition, these phenomena were left suspended in the realm of not yet known. Scientists, true to their method, refused to embellish. They did not call shadows fragments, nor did they erase anomalies that persisted. They left them standing, marked with caution, unresolved, not forgotten. This restraint was itself a message. For the public, it was a reminder that science does not close every door. It illuminates some and marks others for future return. The calm of the reports was not apathy but discipline, an insistence that unanswered questions remain part of the story. Atlas had dazzled, unsettled, and then frightened, but in the end, it demanded respect not just for what was known, but for the discipline of leaving mysteries intact until evidence matures. In classrooms and lecture halls, this became the final lesson. Professors explained that distinguishing signal from noise is not a matter of brilliance but of patience, of rules applied consistently. They compared it to tuning a radio through static, where the melody emerges only if one resists the temptation to call every sound music. Students, inspired by Atlas, began to see that the true beauty of science is not only in discovery, but in restraint, the courage to admit limits without surrendering curiosity. And so, Part 12 closed in quiet balance. Humanity had gained durable knowledge: the dust and plasma engine, the chemistry of the emerald glow, the measurable mechanics of non-gravitational thrust. Yet it had also inherited open questions: the swarm that might or might not exist, the opaque coma that defied easy modeling, the rhythms that teased at hidden processes. The discipline of separating signal from noise had delivered satisfaction without finality. It reminded humanity that every answer refines the questions, and that the sky is not obliged to speak clearly. In this, Atlas left a final echo: that truth, when it comes, is never a single burst of light but a gradual filtering of shadows. Science is not the end of mystery, it is the method by which mystery is carried forward with integrity, calm, disciplined, unfinished. And in that unfinished state, the universe remains open, inviting the next comet, the next signal, the next test of patience and rigor. By September 2026, Atlas was little more than a receding entry in astronomical logs, its emerald blaze long gone from the skies. Yet, the imprint it left was not erased. What endured was not just data, but reflection on the ways human beings saw it, described it, reacted to it. The comet, alien in appearance, had become less a body in space than a mirror for the human mind. Psychologists observing the public reaction noted familiar patterns. When Atlas's coma grew opaque, people spoke of veils and masks. When its tails writhed near the sun, they imagined dragons, serpents, phoenixes. When rumors of swarms surfaced, speculation turned to fleets, companions, even hidden intentions. None of these metaphors was wrong. They were human. The brain, evolved for survival on Earth, seeks patterns and stories. Faced with something vast and strange, it dresses the unknown in familiar clothes. Atlas looked alien not because it intended to, but because our minds, lacking precedent, had no choice but to translate it into myth. Neuroscientists describe this as apophenia, the tendency to perceive order in randomness. Yet in Atlas's case, the randomness was not empty. The comet truly was unusual, its glow denser than models, its survival defiant, its whispers unresolved. The mind's metaphors were not mistakes, but bridges, scaffolding that allowed imagination to carry comprehension forward. A scientist might insist on equations, but even she, in the quiet of her office, might think of Atlas as a living flame. To do otherwise would be to deny the humanity of perception. And here lay the deeper lesson. Atlas's strangeness did not only reveal the cosmos, it revealed the human tendency to confront mystery with narrative. Every headline, every sketch, every classroom explanation became part of this dance between alien phenomenon and human mind. The comet was a stranger, but the strangeness we saw in it was shaped as much by neurons as by photons. We did not just watch Atlas, we interpreted it, filtered through memory, language, and imagination. The result was a hybrid truth, half comet, half consciousness. This realization carried humility. For centuries, humanity has claimed progress in making the universe less alien, charting orbits, decoding spectra, explaining tails and comas. But Atlas reminded us that no matter how far knowledge extends, perception will always frame it in human terms. We cannot see the universe as it is, we see it as we are. The alien glow, the emerald veil, the whispers of a swarm, they all told us something real about Atlas, but also something about ourselves. That wonder and fear are twins, that knowledge and imagination walk together. In this sense, Atlas was alien only in appearance. The deeper alienness lay in our own minds, in the limits of perception that forced us to paint meaning onto the unknown. The comet departed, but it left behind a reflection, the reminder that every discovery is twofold. One half lies in the sky, the other half lies within the mind that dares to interpret it. In the months that followed, as September gave way to October 2026, the discourse around Atlas shifted from urgent questions to quieter reflections. Scientists still mined its data, but what circulated more widely were essays, lectures, and meditations. The comet's emerald glow had dimmed into metaphor, a symbol of the limits of perception. What people remembered was not the exact spectral lines or the measured thrust of sublimation jets, but the feeling of strangeness and the realization that strangeness was as much a product of the human mind as of the object itself. This shift carried a humbling weight. Philosophers of science reminded audiences that every act of knowing is also an act of framing. We build instruments, we record signals, we strip away noise, but the final interpretation must pass through language, through imagination, through the finite brain. Atlas looked alien not because it defied physics, but because physics, when refracted through human sight, must always be translated. The comet was a visitor from another system, yes, but it was also a visitor to our minds, forcing us to recognize the boundaries of cognition. Examples abounded. When the opaque coma refused to reveal the nucleus, we described it as a mask. But that word said as much about our psychology as it did about the comet. When plasma tails writhed in the sun storm, We spoke of serpents or banners. Yet the writhing was not conscious. It was magnetic turbulence dressed in metaphor. These words were not mistakes, they were scaffolding. Attempts to render the inhuman into human categories. Atlas had not lied to us. We had clothed it in stories. And perhaps that was inevitable, for knowledge without story rarely takes root. The recognition of this interplay fostered a rare humility. Scientists admitted openly that while they had decoded much the dust engine, the plasma dynamics, the chemical glow, they had not captured the whole. The swarm remained ambiguous, the coma paradox unresolved, the rhythmic pulses unclassified. But instead of frustration, many spoke with calm acceptance. The purpose of science was not to eliminate mystery, but to discipline it, to carry it forward with integrity. In this, Atlas became a lesson in both epistemology and humility. The mind seeks to know, but it must also learn to live with the unknown. For the public, this humility was oddly reassuring. It told them that science was not arrogance, but patience, not omniscience, but method. Atlas had looked alien, and in that alienness we projected fear, awe, and imagination. But when the noise settled, what endured was not the illusion of mastery, but the discipline of perspective. Humanity had stared at something vast and strange, and instead of declaring conquest, it admitted limitation. That act of honesty became its own kind of victory. Thus, Part 13 closed not with closure but with reflection. Atlas had been alien in look, yet its deepest lesson was human, that perception is both gift and boundary, that knowledge expands but never abolishes mystery. The comet's true mirror was not its emerald light, but the recognition it awakened that to encounter the universe is always to encounter ourselves, refracted in the glow of the unknown. By October 2026, the fever of speculation had cooled, and what remained was a sober effort to chart the possible futures Atlas had revealed. Scientists, policymakers, and even insurers gathered around the same question. What if another object arrived, as strange, as unpredictable, as stubbornly alien-looking as Atlas? The answer, they agreed, depended on how clearly humanity could distinguish between worst-case and best-case scenarios. The worst case was not difficult to imagine. Even without a direct collision, an interstellar body like Atlas carries risks that cascade across systems. A dense swarm of fragments, if real, could strike orbiting satellites, crippling communication or navigation networks. A plasma storm, if amplified by solar interaction, could induce geomagnetic currents strong enough to overload electrical grids on Earth. Even subtle orbital perturbations might force costly maneuvers from spacecraft already in fragile balance around Mars or in Earth's high orbits. History had provided warnings. Jupiter's wounds from Shoemaker Levy, 9 inches, 1,994, auroral storms unleashed by solar coronal mass ejections, and the vulnerability of satellites exposed during the 1989 Quebec blackout. Each precedent whispered a reminder. The cosmos did not need to aim for Earth to disrupt human life. The greatest danger, ironically, was not physical impact but systemic fragility. Humanity's infrastructure, satellites, power grids, internet cables depended on assumptions of stability. A single miscalculation, amplified by an event like Atlas, could ripple into crises of communication, energy, or even food supply. That was the true worst case, not an apocalypse from the sky, but cascade failure from within. It was a sobering vision, but it carried value. To imagine the worst was not to surrender to fear, but to prepare, to stress test the systems that modern life had built upon. And yet, even within the same data, the best case emerged just as vividly. Atlas had demonstrated that an interstellar comet could survive close approach to the Sun, that its signals could be tracked across hemispheres, and that the global scientific community could, within months, assemble a unified model from fragmented observations. The comet had frightened, yes, but it had also galvanized. Funding for planetary defense increased, international collaboration deepened, public awareness broadened. In classrooms, children now spoke of comets not just as omens but as challenges to be understood. In universities, engineers sketched designs for rapid response missions, projects that might otherwise have languished. Atlas had, in effect, served as a free rehearsal, an uninvited guest that nonetheless left behind tools for resilience. Thus, the contrast sharpened. In the worst case, interstellar visitors expose fragility. In the best case, they inspire preparation. The difference lay not in the cosmos, but in humanity's response. The skies would send what they would. It was Earth that chose how to interpret, how to prepare, how to act. This framing carried both tension and hope, a reminder that risk is never absolute but always relative to readiness. Atlas had looked alien, but in its reflection, humanity saw both its vulnerabilities and its capacities. That balance was the truest echo of October, controlled tension paired with cautious optimism. In the weeks after the October reports, discussions shifted from abstract possibility to pragmatic design. It was not enough to define worst case and best case in theory. The challenge lay in building systems that could bend toward the latter. Analysts spoke of resilience planning, the practice of preparing for disruption while cultivating opportunity. In this light, Atlas became less a cosmic anomaly and more a test case for how humanity should think under pressure. The strategy unfolded in layers. At the technological level, agencies recommended fortifying satellites with radiation shielding, designing constellations with redundancies so that the loss of a few would not cripple entire networks. Power grid operators reviewed contingency protocols for geomagnetic storms, integrating lessons from Atlas's plasma outbursts with long-standing solar weather data. Spacecraft engineers drafted designs for modular probes, lightweight vehicles that could be launched rapidly to intercept future visitors, turning mystery into measured knowledge before rumor could metastasize into panic. At the policy level, the echoes of Atlas encouraged unprecedented cooperation. Nations that rarely shared data began discussing transparent protocols for reporting anomalies. Insurance firms, once silent partners, now sat at the same tables as astrophysicists, translating cosmic uncertainty into actuarial risk and thereby into budgets. Even defense ministries, wary of threats cloaked as natural events, engaged in dialogue not about weapons but about resilience. The comet had drawn unlikely allies into the same room, bound less by fear than by recognition of shared vulnerability. And at the cultural level, the best-case scenario took root in how people imagined the future. Popular media stopped treating comets solely as harbingers of doom. Instead, they became symbols of vigilance and curiosity. Children asked not whether the next comet would destroy Earth, but whether they might be the ones to build the probes that meet it. Documentaries closed, not with warnings but with invitations to study, to participate, to remain awake. The comet's alien glow had unsettled, but it had also ignited a quiet pride that humanity could confront the unknown without flinching. None of this erased the risk. The worst case remained a shadow at the edge of the discussion, a reminder that no preparation is perfect. But within that shadow lay the seed of humility, and humility itself became a form of hope. To acknowledge limits was to avoid arrogance. To prepare despite uncertainty was to assert resilience. The comet had taught that safety is never guaranteed, but preparedness can tilt probabilities, shifting the balance toward survival, even toward progress. And so, Part 14 closed not with dread nor with triumph, but with the tempered steadiness of a species learning to live with cosmic risk. The worst case could not be ignored. The best case could not be assumed. Between them stretched a spectrum of possibilities, navigable only through discipline, cooperation, and imagination. Atlas had forced Earth to rehearse that navigation, and in doing so, it left behind more than data. It left a mindset. Controlled tension, cautious optimism, the readiness to meet the next Emerald Wanderer not with panic, but with practiced calm. By December 2026, Atlas was gone. No telescope could catch its fading shimmer. No radar could chase its echo. It had crossed the invisible boundary, retreating toward the interstellar dark from which it had come. Yet the absence did not feel empty. Instead, it carried the quiet weight of presence, like a bell that had rung and left the air vibrating long after the sound itself had vanished. Humanity no longer looked up to see Atlas, but inward, to feel what it had revealed. The comet had been many things: a plume of dust and plasma, a puzzle of swarms, a teacher of scientific discipline. But in its departure, it became something else. A mirror, not of glass or polished stone, but of cosmos itself. A reflection that showed humanity not just a comet, but its own longing to understand, its own fragility, its own courage to face the unknown. Atlas had looked alien, but its true strangeness was the way it forced us to see ourselves. Looking back, people spoke less of data points and more of impressions. The Emerald Veil was remembered as awe, not wavelength. The whisper of swarm fragments was remembered as suspense, not probability curves. The plasma storms were recalled as beauty, not as electromagnetic turbulence. Memory transfigured the science into a story, and that story was not about a comet alone, but about human beings standing under a sky too vast to own, too mysterious to master. And this, perhaps, was Atlas's final lesson. That knowledge is never the opposite of mystery, but its companion. That awe does not fade when equations are written, but deepens, taking new form. To chart a comet is to chart ourselves, the questions we ask, the limits we face, the patience we practice. In the emerald blaze of Atlas, we saw both the alien cosmos and the mirror of the human mind. Its departure was not an ending, but a reminder that the cosmos does not close its doors. It simply invites us to walk further. Thus, as 2026 ended, humanity found itself standing at the threshold of quiet reflection. Atlas was gone, but its mirror remained, hanging not in the sky but in the imagination. What it reflected was not only science, but humility, not only curiosity, but the fragile hope that to live is to keep asking, to keep seeking, to keep listening. In its silence, the comet left us with something louder than spectacle, the understanding that we, too, are travelers in a cosmos that will always be larger than our grasp, yet always open to our gaze. As the year drew to its close, the narrative of Atlas no longer belonged solely to astronomers or policymakers. It belonged to everyone who had looked upward and felt the silent tug of something greater. For schoolchildren, it became the story of the emerald visitor that lit the sky. For scientists, it remained a dataset, dense with signals and stubborn with noise. For philosophers and poets, it became a metaphor, an emblem of the infinite. In each context, Atlas reflected something different, yet in every reflection, it carried the same truth. The universe is not ours to control, only to witness, to interpret, to respect. There was a humility in this recognition, but also a quiet strength, for if Atlas had shown how small humanity was against the scale of the cosmos, it had also shown how vast human curiosity could be. The comet crossed light years of void, indifferent and unknowing, yet it drew entire civilizations to pause, to measure, to debate, to imagine. That act of collective attention was itself a kind of resilience. We may be fragile, the comet seemed to say, but in our seeking lies a power the void cannot erase. This double vision of fragility and of resilience settled into the cultural memory like sediment in deep water. It did not erupt in headlines, but in quiet realizations. A child choosing to study astronomy, an engineer sketching safer satellites, an artist painting the emerald glow not as omen but as invitation. These were not loud responses, but they were enduring. In the mirror Atlas left behind, people found not panic, but perspective. The sky was no less strange, but strangeness had become a teacher, not a threat. And so the finale arrived not with fanfare, but with stillness. Atlas was gone, yet in its place it left a silence filled with meaning, the kind of silence one finds in cathedrals, or in forests at dusk, or under the stars on a clear winter night. It was a silence that did not demand answers, only presence. Humanity, for a rare moment, felt not the urge to conquer the unknown, but to stand within it, to breathe with it, to accept it. This was the mirror of the cosmos, not a reflection of control, but of communion. Atlas had come and gone, yet in its arc across the solar system, it had etched a subtle reminder into our collective memory that we, too, are passing travelers, luminous for a while, fading into the dark, yet leaving behind echoes in the minds of those who watch. Its emerald veil had dissolved, but its lesson endured, that to live under the cosmos is to balance fear with awe, fragility with courage, questions with silence. And as the year closed, hope took root in that silence. Hope not of certainty, but of continuity. The knowledge that the cosmos will send more visitors, and that we will meet them with eyes open, hearts steady, and minds willing to reflect. Atlas was gone, but the mirror it held up remained, bright enough to guide us into whatever mysteries wait beyond the horizon of night. As March 2026 dawned, Atlas slipped deeper into the sun's dominion, and the spectacle intensified. From solar telescopes, the images resembled a duel between color and fire, the golden arcs of the corona flaring outward, and within them, the emerald veil of the comet bending, twisting, refusing to vanish. Plasma storms raged across the solar surface, violent eruptions taller than Earth itself, yet Atlas persisted within their glow. Each time a coronal mass ejection rippled outward, scientists feared the green flame would be shredded into oblivion. Instead, the coma shuddered, expanded, and seemed almost to pulse brighter, as though the sun's assault only fed its strange vitality. The physics explained part of the mystery. As the comet's frozen core sublimated at furious rates, the released gases became ionized by the sun's radiation. Once ionized, they fluoresced in emerald hues, a glow magnified by the sheer density of the coma. Magnetic fields caught these ions and whipped them into long streamers, turning the tail into a tapestry of light. To instruments, it was a predictable chain of reactions: sublimation, ionization, solar-wind interaction. But to the human eye, the effect transcended explanation. It looked alive. The tail writhed like a serpent through the corona, a luminous creature wriggling against the weight of a star's fury. Observers described it with words reserved for dreams and nightmares: beautiful, terrifying, unearthly. Ground-based observatories released time-lapse footage, and millions watched as Atlas seemed to dance on the edge of annihilation. In sped-up sequences, the emerald shroud bent and flared, curling as if in pain, then unfurling like a banner caught in a cosmic gale. Social media was flooded with comparisons. Some saw a phoenix rising from fire, others a spectral dragon coiling against the Sunday. Artists painted it as a cosmic duel between creation and destruction, between emerald and gold. Yet beneath the poetic metaphors lay a silence of dread. The spectacle was stunning, but it carried with it the awareness that beauty could be merciless. For scientists, the event was both a gift and a torment. Instruments captured torrents of data, spectral lines thick with ionized oxygen, fluctuating brightness that hinted at turbulence in the coma. Yet every new measurement widened the riddle. Atlas should have been breaking apart under such heat and radiation. Comet Ison had disintegrated under less. Instead, Atlas seemed to adapt. Was its core larger than suspected, massive enough to resist? Or was there some composition, some unknown chemistry, that allowed it to endure? Each possibility carried implications that unsettled established models. The sun was supposed to be the great equalizer, the power no comet could withstand. And yet here was Atlas, surviving within its glare, mocking the expectation of fragility. The public felt the contradiction viscerally. Watching live streams, people gasped at the green flame shimmering inside golden fire. They spoke of feeling small, of sensing mortality, of being humbled, yet they could not look away. The spectacle had become a kind of mass hypnosis, a reminder that awe and fear are siblings. In the emerald light of Atlas against the sun's blaze, humanity saw both its fragility and its hunger for wonder. It was Rern-Rern-Det beauty sharpened into something that left the heart unsettled. A beauty that reminded everyone how thin the line is between survival and annihilation. And still, the comet moved closer, deeper, into the very place where light itself seems to die. By mid-March 2026, Atlas had reached its moment of truth. Perihelion, the closest point of its arc around the Sunday. In ancient times, cultures might have seen such a sight as a prophecy, a divine omen painted across the heavens. Even in an age of satellites and spectrographs, the effect was no less overwhelming. Images streamed from the Solar and Heliospheric Observatory showed the comet's emerald haze burning within the golden sea of the corona, the tails stretching like luminous scars across the void. For a few hours, the spectacle consumed the world's attention. Astronomers huddled around monitors, journalists filled broadcasts with breathless narration, and ordinary people stared at live streams with mouths half open. Humanity watched not just a comet, but a confrontation between fragility and fire. The science was staggering. At perihelion, Atlas endured temperatures near 2,000 degrees Celsius. Its surface boiled furiously, shedding millions of tons of material every second. Jets erupted like geysers, feeding a coma so vast it rivaled the sun's own prominence loops in appearance. Yet the nucleus itself, still hidden, refused to reveal whether it was intact, shattered, or something stranger still. Instruments detected fluctuations in brightness, sudden surges that suggested fragmentation, but none confirmed collapse. Instead, Atlas seemed to emerge from each assault brighter, as if every wound from the sun became another source of light. It was a spectacle, as paradoxical, physics wrapped in poetry. Observers wrestled with awe. For scientists, the event was a test of theory. For poets and philosophers, it was revelation. Here was a visitor from the interstellar dark, daring to embrace the furnace that had shaped Earth and life itself. Some described it as a death march, a body offering itself to the Sunday. Others saw in it defiance, survival against impossible odds. The imagery unsettled everyone. Was Atlas dying or transcending? Was this the last vision of a wanderer consumed, or the birth of a new form, baptized in fire? The ambiguity was what made it beautiful and terrifying. The public's response was electric. Social networks erupted with images captioned the Emerald Survivor or the Green Sacrifice. Religious leaders invoked it in sermons, some proclaiming it a sign of renewal, others a warning of humility. In classrooms, teachers replayed footage, explaining solar winds and sublimation, while students sat transfixed, more moved by the vision than the words. Even skeptics admitted to being shaken. The sight of green flame twisting inside the sun's golden blaze was not something that could be filed away as routine astronomy. It was myth, science, and existential dread fused into one. And then, as quickly as it had peaked, the encounter passed. Atlas arced around the sun, its path curving outward again into the wider system. Whether it had survived intact or left fragments trailing remained uncertain, hidden for now by the glare. But its performance lingered in human minds. The sun had not erased it, at least not completely. That fact alone unsettled assumptions. For if even the sun could not silence this visitor, what did that say about its true nature? The mystery only deepened, but the emotion was clear. Humanity had stood witness to a moment both rapturous and dreadful, a vision that felt like a warning and a gift at once. Atlas had plunged into the fire, and against expectation, left behind a memory that would haunt imaginations for years to come. And as the emerald glow drifted outward again, a quiet question echoed beneath the ore. What had truly emerged from the furnace? The same wanderer, or something changed forever? By late March 2026, as Atlas emerged from its fiery encounter with the sun, the world exhaled in relief. It had not disintegrated completely, as many had predicted, yet almost immediately, new whispers of unease began to surface. Observatories tracking the comet's outbound trajectory began to notice peculiar anomalies, faint, flickering signals that seemed to accompany its emerald trail. To the untrained eye, these were nothing but noise, specks lost in the glare of a still monstrous coma. But to specialists, the anomalies were disquieting. They hinted at something more: fragments, companions, or perhaps a swarm. The data arrived piecemeal, like pieces of a puzzle scattered across the globe. In Chile, astronomers noted sharp dips in brightness, as though smaller bodies were casting shadows within the coma. In Japan, radar pings returned echoes inconsistent with a single nucleus, as if multiple reflectors lurked within the haze. In Hawaii, long-exposure images captured faint streaks, faintly diverging from the main trajectory, subtle but persistent. Each observation could be explained away as noise, instrumental error, cosmic rays, or processing artifacts. Yet taken together, they painted a picture that was difficult to ignore. Atlas might not be alone. It might be shedding fragments, or worse, carrying a convoy of smaller bodies invisible until now. Scientists were cautious in their language. No one wanted to repeat the mistakes of overstatement. Reports used phrases like secondary bodies possible, anomalous scatter detected, and further confirmation required. But beneath the restraint lay a deeper current of worry. If a swarm truly accompanied Atlas, then every assumption about its behavior would have to be revised. A solitary comet was one thing. A cluster, moving at interstellar velocity, was another entirely. The implications stretched beyond curiosity. Each fragment, no matter how small, carried the potential for unpredictable interactions with Mars, with satellites, even with Earth's orbital defenses in the future. The global eye network became a hive of speculation. In encrypted chat rooms, young astronomers swapped theories late into the night. Some argued that the swarm was merely debris vented during perihelion, harmless dust glowing in the sun's rays. Others feared the fragments were coherent, nucleus-sized shards, each capable of carving its own path through the solar system. The debates grew heated. "We can't even agree on whether we're seeing shadows or signals," one participant lamented. The uncertainty was suffocating, for the data refused to yield clarity. One night's observation would suggest structure, the next would dissolve it into haze. The swarm hovered in the realm of possibility, unconfirmed yet impossible to dismiss. For the public, the idea was both thrilling and frightening. News outlets latched onto the phrase the swarm hypothesis, framing it as the next chapter in Atlas's unfolding drama. Headlines asked, "Is the comet breaking apart? Are fragments racing with it?" Animated graphics showed clusters of glowing shards trailing behind a green giant, each one a potential messenger or menace. Social media buzzed with speculation, memes mixing awe and dread. Ordinary people felt the suspense acutely. They had watched Atlas survive the sun. Now they wondered what secrets it might be hiding in its shadow. The possibility of a swarm turned the comet from a single mystery into a chorus of unknowns, multiplying both wonder and unease. And so, the tension deepened. Atlas had emerged from the fire intact, but its silence had returned in a new form, broken into whispers, scattered across the sky, too faint to resolve, too persistent to ignore. Humanity once again found itself staring upward, hearts caught between fascination and fear, waiting to know whether those whispers were illusions or heralds of something far more real. As April 2026 opened, the debates coalesced around two starkly different interpretations. The first was the best-case scenario, that the swarm was little more than dust, harmless clouds of particles shaken loose during Atlas's passage near the Sunday. In this version, the comet's radiant emerald shroud was hiding nothing more dramatic than microscopic debris, glowing faintly as it reflected solar light. Such dust, though spectacular in appearance, posed little threat. It might seed faint meteor showers, drift harmlessly into the void, or scatter into invisibility before reaching any planetary body. Advocates of this view pointed to known examples comets whose perihelion outbursts produced elaborate dust fans without ever fragmenting into dangerous shards. To them, the swarm hypothesis was less a revelation than a trick of perception, the human mind, eager for drama, painting monsters onto shadows. But the worst-case scenario lingered like a storm cloud. In this interpretation, the anomalies were not dust at all, but solid fragments, pieces of nucleus torn free by stresses too great for any single body to endure. These fragments, large enough to reflect radar and persistent enough to maintain coherence, would follow trajectories only loosely tethered to the parent. At interstellar speeds, even a boulder-sized shard could carve destruction into any spacecraft unlucky enough to cross its path. For Mars orbiters still recovering from Atlas's earlier passage, the possibility of a fragmentary swarm was no small concern. Engineers issued advisories, running simulations of impact probabilities, rehearsing evasive maneuvers that they prayed would never be needed. Between these poles stretched a spectrum of uncertainty. Some suggested the swarm might be a mix, dust clouds hiding a handful of larger companions, a wolf concealed in a flock of sheep. Others wondered if Atlas itself was never a single nucleus, but a loose cluster bound together by gravity, now unraveling under solar stress. If so, then humanity had not been watching a solitary traveler at all, but the disintegration of an interstellar convoy. The very idea unsettled researchers. It implied that what we called a comet could, in fact, be an entire family of bodies, disguised as one. The data remained ambiguous, refusing to collapse into certainty. Some nights, telescopes caught streaks that seemed to diverge a hint of separate objects. The next night, those streaks vanished into noise. Radar echoes suggested multiple reflectors, but statistical analysis blurred them back into doubt. The swarm hovered in limbo, neither confirmed nor denied, existing as a possibility that refused to die. And it was precisely that uncertainty that gnawed at nerves. If the swarm was real, it was already here, already moving, already rewriting expectations. If it was an illusion, then the persistence of its signals raised another unsettling truth, that our instruments were perhaps not as reliable as we believed. Both outcomes carried discomfort. For the public, suspense became the dominant mood. News channels dramatized the divergence of scenarios with colorful graphics. In one, Atlas trailed glittering dust, beautiful and harmless. In another, shards peeled off like a fleet of ghostly ships, their paths unpredictable. People argued in online forums, some cheering for the dust dreamers, others warning of the fragment truthers. Conspiracy theories flourished, claiming agencies already knew the swarm was real, but were suppressing evidence to avoid panic. Official denials did little to stem the tide. The very fact that scientists admitted uncertainty only deepened the fascination. And so the world lingered in that liminal space between hope and dread. Every new report felt like the turning of a page in a novel whose ending remained hidden. Was Atlas scattering harmless sparks, or was it shedding companions with stories of their own? Humanity could not yet tell. The swarm hypothesis lived on as a shadowy possibility, a suspense that demanded patience but refused comfort, a mystery that seemed determined to test not only science, but the nerves of all who watched. By mid-April 2026, the swarm hypothesis had become less a fringe notion and more a shadow draped across every discussion of Atlas. What unsettled observers most was not confirmation, but the lack of it. Data continued to arrive in fragments, a radar blip here, a brightness dip there, spectral lines that hinted at multiple sources but dissolved into noise under scrutiny. It was a chorus of whispers, never resolving into a single clear voice. Yet the persistence of those whispers gnawed at confidence. If the swarm did not exist, why did the anomalies refuse to vanish? Within the Global Eye network, the atmosphere grew tense. Teams that once traded ideas with excitement now spoke in clipped, weary tones. Some pressed for caution, arguing that too much weight was being placed on signals barely above noise. Others pushed harder, insisting that the very ambiguity was itself the warning that nature rarely repeats the same anomaly without cause. "We are staring at shadows on the wall," one astronomer remarked during a late-night call. But shadows are cast by something. The statement hung heavy, encapsulating the mix of frustration and dread that now defined the debate. Public anticipation only magnified the unease. Each press release, however measured, was dissected by commentators hunting for hidden meaning. When agencies described the anomalies as statistically persistent, audiences heard instead, "We cannot rule it out." Online feeds buzzed with speculation. What if Atlas was not a comet at all, but a fragmented cluster wandering through our system? What if its emerald glow was the veil of an entire family of travelers? Theories spun outward, some imaginative, others alarmist. The truth that no one knew was both the most honest and the most frightening answer. The suspense carried echoes of earlier cosmic surprises. People recalled how Oumuamua had been declared an interstellar rock only after its odd acceleration defied expectations. They remembered how Borisov, though more comet-like, carried chemistry that baffled models. In that context, Atlas's swarm signals felt like the next step in a pattern. Each new visitor, stranger than the last, each one refusing to fit the neat categories of textbooks. If this trend continued, what might the fourth visitor reveal? The question was thrilling, but it left a knot in the stomach. The galaxy seemed intent on reminding humanity that its surprises were only beginning. What made the swarm hypothesis uniquely unsettling was its intimacy. A massive single body, however threatening in theory, was at least predictable in motion. A swarm was chaos embodied, fragments scattering, paths diverging, probabilities multiplying until certainty collapsed. To live under a sky that might harbor such a swarm was to live under suspense itself, a reminder that the cosmos was not a fixed stage, but a shifting crowd of actors whose movements we could not script. And so, April closed with a paradox of its own. No fragment had yet been confirmed, and yet the fear of fragments colored every observation. The swarm hypothesis remained suspended, neither proven nor disproven, like a question mark carved into the night. Humanity stood before it, with the same uneasy patience it had shown since Atlas first appeared, waiting, watching, listening for the moment when shadows would finally sharpen into form. Whether those forms proved harmless or perilous was a truth still withheld, but the suspense itself had become part of the story, and in that suspense lay both wonder and worry, the twin companions of every gaze cast toward the Emerald Traveler. By May 2026, with Atlas receding from the inner system, scientists finally had the time and the data to ask the deeper question: what powered the Emerald spectacle? The answer, at least in part, was both elegant and unsettling. Atlas had revealed itself not merely as a comet, but as something closer to a natural engine, a body propelled and reshaped by forces of dust and plasma. The mechanics began with sublimation. As the comet's nucleus still unseen, still cloaked, heated under the sun's relentless fire, its frozen ices transformed directly into gas. This gas erupted outward, dragging clouds of dust with it, much like steam whistling from a kettle. Each jet, though microscopic compared to planetary scales, carried momentum, and momentum, multiplied by billions of tons of expelled material, translated into thrust. Atlas was not drifting passively through space. It was firing, pulsing, steering itself with every outburst. But sublimation alone could not explain the emerald fire. The second ingredient was plasma. Once released, the gases were bombarded by solar radiation, ionizing them into charged particles. These particles glowed green, not by accident, but by chemistry, oxygen ions fluorescing at specific wavelengths, amplified by the sheer density of the coma. Then came the solar wind, streams of charged particles rushing outward from the sunday. When these winds collided with Atlas's plasma sheath, the result was not chaos but structure. Magnetic fields shaped the ions into tails, whipping them across millions of kilometers. To the eye, it was art. To physics, it was mechanics. The coma and tail were no longer passive veils. They were dynamic exhaust plumes of a colossal, unintentional engine. Observers marveled at how the effect mirrored human technology. Rocket engines expel gases to generate thrust. Atlas expelled dust and plasma. Spacecraft rely on ion drives. Atlas radiated ions into space, guided by natural fields. It was as if the comet had stumbled upon the same principles humanity had only recently begun to harness, but on a scale vaster and stranger. This recognition carried a strange satisfaction, as though nature had written equations long before we did, and was now demonstrating them in the sky. And yet, satisfaction came tinged with unease, for if Atlas was an engine, it was one without a driver, a machine running on laws alone. It was easy to imagine the comet as purposeful, as though it chose to resist destruction, but scientists reminded themselves that this was an illusion. Atlas did not intend. It simply obeyed. Still, the metaphor lingered. To witness the dust and plasma engine was to glimpse design, where there was none, to sense agency in mechanics. That sensation thrilled and unsettled in equal measure, a reminder that the line between knowledge and mystery is as thin as a veil of emerald light. The satisfaction of discovery grew stronger as scientists began placing Atlas within a lineage of comets already studied. There was precedent for dust-driven thrust. Halley's comet, observed for centuries, has always defied prediction slightly. Its orbit nudged each time it neared the Sun by jets of sublimating ice. Space agencies had even modeled these non-gravitational forces to refine trajectories. Yet compared to Atlas, Halley seemed tame, its adjustments subtle, its coma transparent. More recently, in 2014, the Rosetta mission revealed the intimate mechanics of 67P divided by Churyumov-Gerasimenko. Cameras showed geysers erupting from cliffs, jets of dust and gas-carving channels in the comet's strange landscape. Researchers watched, delighted, as physics unfolded in real time. The nucleus rotated, the jets sputtered, the orbit shifted. It was the closest humanity had come to standing beside a comet and watching its engine ignite. But Atlas, seen from afar, displayed the same principles at a scale so outsized that Rosetta's images seemed like prototypes. Where 67P sputtered, Atlas roared. Its coma grew larger than planets, its tails lashed millions of kilometers, its brightness overwhelmed sensors. And then there was Isen, the so-called comet of the century, which plunged toward the Sun in 2013 only to be obliterated. Isen was a reminder of fragility. No matter how beautiful a comet's display, most could not withstand the Sun's trial. Atlas, by contrast, survived where Isen perished. That survival alone unsettled expectations. Was its nucleus simply larger, its crust stronger, or was there some unknown mechanism, perhaps the very efficiency of its dust and plasma exhaust, that allowed it to endure heat and radiation that had destroyed others? These comparisons offered a kind of intellectual fulfillment. Each comet became a clue, each observation another gear in the machine of understanding. The dust and plasma engine was no longer speculation. It was a pattern, confirmed across multiple examples and magnified spectacularly in Atlas. The principles of sublimation, ionization, and thrust held. Equations aligned, models improved. Humanity could, with some confidence, say it understood the comet's emerald fire. Yet the satisfaction was tempered by questions that refused to die. Why did Atlas's coma grow denser instead of thinner as it expanded? Why did its plasma sheath pulse with rhythms that instruments struggled to categorize? Why did radar echoes suggest structures too coherent for random dust clouds? Each answer uncovered further puzzles. The dust and plasma engine explained much, but not everything, and in the gaps between knowledge, mystery lingered like static, whispering that the story was not finished. For the public, this duality was intoxicating. Science documentaries declared victory. The comet's green blaze had been decoded, yet the same programs ended with caveats, footage of scientists shrugging and smiling, admitting that Atlas still held secrets. Viewers felt both educated and tantalized, as though they had been invited into a magician's workshop and shown the mechanics of the trick, only to realize the magician still had one hand hidden behind his back. The knowledge satisfied, but it also teased. The dust and plasma engine had illuminated the comet, yet it left the heart longing to know what else lay behind the emerald veil. By late May 2026, the synthesis of data felt like a triumph. Scientists could, for the first time, chart the invisible currents that had sculpted Atlas's journey. Sublimation jets providing thrust, plasma winds shaping its tails, electromagnetic fields guiding its luminous banners. The comet had become a case study in cosmic mechanics, a natural demonstration of principles humanity was only beginning to master in laboratories and spacecraft. For students of astronomy, the satisfaction was profound. Atlas was no longer just a dazzling anomaly. It was a teacher, a green-cloaked lecturer reminding the species of how matter and energy converse in the void. Teams published models that mapped its dust-to-plasma ratios, simulations that predicted its subtle orbital shifts, and projections of how its tail would unravel as it receded into interplanetary space. These results gave the public a sense of closure. Headlines declared, "Mystery solved, Atlas, powered by dust and plasma engine." Documentaries celebrated the ingenuity of global collaboration, how hundreds of telescopes pieced together a narrative from chaos. The triumph was real, and it resonated. For once, humanity had stared at something overwhelming and emerged with comprehension. And yet, under the satisfaction, questions lingered like a pulse no one could quiet. Why had Atlas survived the sun when so many others disintegrated? Why did its coma remain opaque, swallowing starlight with a density unaccounted for? Why did spectral data suggest anomalies that refused to fit standard chemistry? The dust and plasma engine explained the how, but not fully the why. In scientific papers, cautious footnotes admitted that unknowns persisted. In interviews, researchers smiled wryly, conceding that Atlas might still be holding back its final secret. For the wider public, that unresolved edge became part of the fascination. People felt both enlightened and haunted. They had been shown the inner workings of a cosmic machine, yet they sensed the machine was larger than the diagram suggested. It was as though Atlas had permitted humanity to glimpse the gears, but not the blueprint. The comet, still receding into darkness, seemed to wink with its emerald glow, reminding onlookers that knowledge is always provisional, that certainty is never complete. And so, Part 10 closed not with an answer but with a balance, satisfaction in the clarity achieved, and suspense in the mysteries left untouched. The dust and plasma engine had given scientists and citizens alike a framework to understand the comet's grandeur. But as Atlas faded from the inner system, its silence returned, carrying with it the oldest truth of the cosmos that every revelation opens the door to another question. Humanity had gained knowledge, yes, but it had also gained a deeper awareness of how much remains unknown. And in that space between satisfaction and doubt, the story of Atlas continued to glow, unresolved, irresistible, and unforgettable. By June 2026, Atlas was already fading into the outer dark, but its presence lingered like a vibration felt long after the bell stops ringing. Scientists called these lingering vibrations Earthside echoes, not literal sound, but the reverberations of what the comet had forced humanity to confront. In observatories, conference halls, and mission control rooms, the mood was not panic, but a kind of taut, pragmatic suspense. The spectacle had passed, but its lessons remained unfinished. Across agencies, teams compiled mountains of data into unified reports. Radar echoes, spectral readings, plasma models. Each piece was catalogued with the seriousness of investigators, piecing together an accident. The goal was not merely to celebrate discovery, but to prepare for repetition. Because if Atlas had arrived once, another would arrive again. The question was not if, but when. That shift in framing was subtle yet profound, an echo that turned awe into policy. At NASA, internal memos outlined upgrades to the Deep Space Network, expanding its ability to track faint interstellar objects weeks earlier than before. ESA proposed a new array of solar observatories, designed not just to study the sun but to monitor the plasma interactions of comets like Atlas in real time. In Tokyo, JAXA announced preliminary designs for a fast response probe, a spacecraft capable of launching within months to intercept any new interstellar visitor. These were not speculative fantasies. They were budgets, deadlines, and prototypes. The comet had transformed itself from curiosity into a case study, and a case study into a blueprint. The echoes also touched the private sector. Satellite companies, rattled by the possibility of plasma storms and dust showers, began investing in shielding upgrades and redundancy systems. Insurance firms quietly adjusted policies, introducing clauses that accounted for space weather anomalies induced by interstellar bodies. Even investors, normally immune to celestial drama, took notice. Atlas had not harmed Earth, but it had revealed how vulnerable orbiting infrastructure could be. The stock of risk had shifted, and markets listened. For the public, the echoes took a different form. Documentaries replayed Atlas's emerald blaze, but the narration was different now. Where once the tone had been awe, it was now caution. Schools taught about the comet not only as a spectacle but as a lesson in preparedness. Children drew not just pictures of glowing tails, but diagrams of radar dishes and satellites. The fascination had not dimmed, but it had acquired an edge. Awe was still there, but it was practical awe, the kind that builds shelters before the storm. The shift was subtle but unmistakable. Humanity had moved from marveling to measuring, from astonishment to anticipation. Atlas had left no scars, but its Earthside echoes reminded everyone that the next visitor might not be so merciful.